Have you ever looked up at the night sky and felt a profound sense of wonder, a feeling that we are on the cusp of a discovery so monumental it could reshape everything we know about our place in the cosmos? What if I told you that moment might be happening right now, unfolding in the cold, silent void between Earth and Mars? And what if the very people we trust to show us the universe are suddenly, inexplicably, looking away? This isn't just a story about a comet. This is a story about a mystery, a trail of digital breadcrumbs, and a deafening silence from the world's most powerful space agencies. It's a story that asks a simple yet terrifying question. What did they see that were not being shown? Our journey begins on a day that should have been a triumph for astronomy. October 8th, 2025. Far across the solar system, on the rust-colored plains of Mars, NASA's Perseverance rover, a marvel of human engineering, paused its search for ancient life to glance upwards. It captured a series of images of the deep Martian sky, looking for a visitor from another star system, an object known as 3I Atlas. The shots weren't perfect. They were never meant to be. This was a long-distance glimpse from a rover designed to look down, not up. But in science, sometimes a faint clue is all you need to ignite the firestorm. An astrophotographer named Simeon Schmaus, a citizen scientist driven by pure curiosity, took 20 of those rover images and applied a technique called stacking, digitally layering them to amplify the faint light. And as the noise cleared, there it was. Not a dazzling spectacle, but a faint, ethereal smudge of light, a whisper from the void, exactly where the interstellar traveler was predicted to be. Almost immediately, the internet began to buzz. Astronomers, both amateur and professional, started talking, analyzing, and debating what this faint smudge could possibly represent. But as this wave of excitement began to build, something deeply strange happened back on Earth. That very same day, NASA, the agency at the forefront of this discovery, furloughed 15,000 of its employees. 83% of the agency, gone just like that. Think about the timing for a moment. At the precise instant humanity was getting its first look at 3I Atlas from the surface of another world, the world's premier space agency effectively shut its doors. Coincidence? Perhaps, but the universe is rarely that neat. And here is where the mystery deepens into something that feels less like a coincidence and more like a deliberate act. The Perseverance rover was not our only eye in the Martian sky. Orbiting high above was NASA's Mars Reconnaissance Orbiter, equipped with the legendary Higher IC camera. This is an instrument of breathtaking power, capable of seeing features on the Martian surface smaller than a car. Its resolution is 30 times better than what Perseverance captured. And on October 8th, it was positioned perfectly for the shot of a lifetime, aimed at the exact corridor of space where 3I Atlas would pass, joining it with the European Space Agency's Mars Express and ExoMars orbiters, each with their own suite of sophisticated instruments, all watching, all waiting. We should have been flooded with images of unprecedented clarity. We should have seen the heart of this interstellar visitor. We should have had our minds blown. Instead, we got nothing. A wall of absolute, deafening silence. But into that silence, other voices began to emerge. Voices from the fringes that spoke of things that seemed impossible. Months earlier, back in August, a group of remote viewers individuals who claimed the ability to perceive distant or unseen targets using their minds were given a set of coordinates with no context. They began to describe an ancient, icy object traveling through space. But they also detected something else, something that didn't belong. They described a piece of technology, no bigger than a thumb drive, deliberately placed deep inside this ancient comet, broadcasting faint, rhythmic impulses. They described this months before our most powerful telescopes, like the James Webb Space Telescope, began detecting chemical compositions in the object that scientists called impossible. A message in a bottle, they called it, sent across the galaxy. This is where our investigation truly begins, and it's a story so vast and intricate that we need a roadmap. This video is divided into two parts. The first half is a deep dive into the mystery of 3I Atlas, exploring every new piece of evidence, every anomaly, and every chilling silence. The second half will broaden our view to cover the other extraordinary space news unfolding this very week. Because what's happening with 3I Atlas is not happening in a vacuum. Timestamps are in the description if you wish to navigate this cosmic rabbit hole at your own pace. But before we venture further, I have to ask for your help. If you find this story as fascinating and as important as I do, please hit that like button and subscribe to join our community of cosmic detectives. More than anything, I want to hear from you. Tell me in the comments where you are listening from, what time it is in your corner of the world, and what your gut tells you this object really is. Is it a natural, albeit bizarre, comet? Or is it something more? If you want to help our community grow and get this story out there, please share this video on X, Facebook, Reddit, or your messenger of choice. Thank you for always supporting our quest for answers. Now, let us turn to the first piece of explosive evidence that turned this from a scientific curiosity into a global obsession. Let me show you something that appeared on Twitter just 48 hours ago and changed everything. A user named UFO Mania, an account known for its speculative content, posted an image that sent shockwaves through the online astronomy world. The caption was simple and bold: "The newest and closest of 3I Atlas, as it passes, is not a comet. It is perfectly cylindrical." The post included an enhanced image, seemingly from an amateur astronomer, showing a starkly elongated object against the black of space. Within hours, it had been shared thousands of times, igniting a firestorm of debate. Now, I know what you might be thinking. An unverified image from an account called UFO Mania? It's easy to dismiss this as just another internet conspiracy, another blurry photo from a backyard telescope. But that's what makes this different. This wasn't some random, blurry light in the sky. When the experts looked closer, they found that the coordinates in the image matched the exact location of 3I Atlas. The timing of the observation matched its flyby of Mars. And most importantly, the deafening silence from official channels matched the growing suspicion that something extraordinary was being hidden. Because here is the fact that nobody can explain away. On October 8th, when 3I Atlas made its closest approach to Mars, a mere 29 million kilometers away, we had the best seats in the house. Multiple spacecraft with multiple advanced instruments from multiple different countries were all watching. We were poised to get the best resolution images ever captured of an object from another star system. And what did we get from these billion-dollar programs? Nothing, not a single pixel. We got silence. And into that silence stepped a single electrifying image of a perfect cylinder in the Martian sky. The question is no longer just, what is 3I Atlas? The question is, why are we not being allowed to see it? In the vacuum of official information, a new kind of investigation began to take shape, not in sterile laboratories or government press rooms, but in the sprawling, chaotic digital ecosystem of the Internet. It was here, amidst the noise and speculation, that a trail of clues began to emerge, a series of digital breadcrumbs that were far more detailed, more technical, and frankly, more terrifying than a single blurry photograph of a cylinder. Just as the furor over the UFO Mania tweet reached its peak, a new, more mysterious account appeared on the scene. It called itself 3I Atlas Anomaly, and it didn't post blurry images or wild accusations. Instead, it began posting a meticulous technical breakdown of the object's behavior, a breakdown that was far too sophisticated for a typical conspiracy theory. It laid out 10 specific points, each one citing actual scientific observations, each one a thread in a tapestry of impossibility. Let's walk through this digital evidence together, because this is where the mystery transcends speculation and enters the realm of hard data. The account pointed to observations from the James Webb Space Telescope, our most powerful eye on the universe, which revealed that 3I Atlas was shrouded in a coma, the gassy envelope surrounding a comet's nucleus that was inexplicably rich in carbon dioxide. Imagine a visitor from another world whose very breath is alien. Then it cited data from NASA's Swift Observatory, which detected unusual emissions of water and hydroxyl, another piece of the chemical puzzle that just didn't fit. But the most baffling clue was something called its polarimetric signature. Now, that sounds complex, but think of it like this. When sunlight bounces off the dust cloud around a comet, it becomes polarized, just like light passing through a pair of sunglasses. By measuring that polarization, scientists can learn about the size, shape, and texture of the dust particles. We have measured the polarization of hundreds of comets. We know what they're supposed to look like. 3I Atlas, however, was a ghost in the machine. It exhibited a negative polarization of -2.77% at a specific phase angle, a combination of measurements that has never, ever been seen before. Not in any comet, not in any asteroid, not in any object we have ever cataloged in our solar system or beyond. This wasn't just an oddity. It was a statistical ghost. It was a fingerprint with no match in any database on Earth. Think about what was happening here. This wasn't vague speculation. This was an anonymous account on the internet citing real instruments, real measurements, and real scientific papers that were just beginning to be published. And as the scientific community whispered in confusion, the online conversation took an even more dramatic turn. A Twitter user named Money Penny, who identified herself as an expert in plasma phenomena, and critically, a former BBC investigative journalist, posted something that made even the most hardened skeptics pause. She didn't just post a theory. She named a name. She claimed that a leading real-world cosmologist named Stephen Burns had come to a shocking conclusion. Burns, she alleged, believes the object isn't just a rock. He believes it is intelligent, surrounded by a shell of dusty plasma, and exhibiting a form of consciousness that has already been communicating with us and with other planets. Consciousness. Communicating. Let that sink in. This is a concept so far outside the bounds of conventional science that it is almost impossible to process. And yet, this wasn't posted in some dark corner of the web. This was in plain sight, from an account with credible credentials, attached to a real name and a background in investigative journalism. And then Money Penny added one final detail that sent a collective chill through everyone who was paying attention. She wrote, "We can no longer look at it, as it is too close to the sun. So, it will now be December before we are able to view it again. December. A 3-month blackout. For 3 months, as this potentially intelligent, conscious object makes its closest and most stressful approach to our star, it will be completely hidden from every single telescope on Earth, tucked behind the glare of the sun. It's the perfect cosmic blind spot." And she posed a terrifying question. During those 3 months, if its trajectory changes, if it decides to go somewhere else, we would have no way of knowing until it re-emerges on the other side. The plot thickened further with a warning from another corner of the internet. A UFO investigator and journalist named Jon Stewart, not the comedian, posted a message that read like a dispatch from a Cold War thriller. "My source has gone dark," he wrote. "NASA is shutting down, and even Congress is in a recess. If 3I Atlas activates, ancient texts warn, the sky will burn with knowing light, and the world will forget its reflection." They called it prophecy. The agencies call it protocol. I call it imminent. Suddenly, hashtags like #AncientTexts, #VaticanFiles, and #The Harbinger began trending right alongside technical discussions of orbital mechanics and spectrography. The conversation had become a bizarre fusion of science, espionage, and prophecy. What do you do with that? How do you separate the signal from the noise when the noise itself might be the signal? Because here is the uncomfortable, undeniable truth that ties all of these threads together. In the last 48 hours, as these posts went viral, as a respected cosmologist was being quoted discussing alien consciousness, as ancient prophecies were being invoked, not a single official image from the Mars flyby has been released. Not from NASA, not from the European Space Agency, not from the Chinese Tianwen-1 mission or the United Arab Emirates Hope Orbiter, all of which had a front row seat. The only visual evidence we have from this historic event, the only picture of humanity's closest look at an interstellar visitor, comes from the patient work of Simeon Schmaus, who stacked those 20 faint rover images to find a faint smudge of light. That's what we got from spacecraft that can resolve a coffee table on the Martian surface. We got a smudge. Unless, of course, what they saw wasn't a smudge at all. Unless they saw something so clear, so unambiguous, and so terrifying that they chose not to show us at all. The silence isn't an absence of evidence. It's becoming the evidence itself. And it begs the question that should keep us all awake at night. What are they protecting us from? While the world's most powerful space agencies maintained their vow of silence, the mystery of 3I Atlas refused to be ignored. It continued to pulse, not through official press releases, but through the digital nervous system of our planet. The anonymous account, 3I Atlas Anomaly, became a source of unsettling truth, posting updates that grew more specific, more technical, and more alarming with each passing day. These weren't wild guesses. They were dispatches from the front line of observation, and they painted a picture of an object that was actively defying our understanding of physics. The first bombshell dropped with just 2 words: unexpected brightening. The object was getting brighter, faster than any of our scientific models predicted it should. Imagine a campfire that, instead of consuming its wood and slowly fading, begins to blaze hotter and brighter without any additional fuel. What could cause such a thing? The account offered the scientific possibilities. Perhaps it was releasing more volatile gases than we expected, or perhaps its outgassing mechanisms were simply more efficient than any we had ever encountered. But behind the technical language was a simple, profound implication. The object's engine, its core process of shedding material, was more powerful than we could explain. It was breaking the known rules of cometary behavior right before our eyes. Then came another update, one that retroactively made the official silence even more suspicious. The account posted, "Spacecraft to observe during solar conjunction." As the object slips behind the sun, ground observations cut off. The European Space Agency is repurposing Mars orbiters to monitor it near the October 3rd Mars flyby. This wasn't a conspiracy theory. This was a confirmation of the operational plan. It verified that the European Space Agency, just like NASA, had specifically tasked its multi-billion-dollar spacecraft to get a close look. Every update the account posted was a verifiable fact, a piece of a puzzle that could be cross-referenced with published scientific data. And yet, when you assembled all the pieces, the image they created was unmistakable. This was a ghost in the machine, an object that looked like a comet, acted like a comet, but was consistently, and in multiple ways, failing to behave like one. And then came the detail that no spreadsheet could capture, and no algorithm could easily dismiss, the one thing that speaks directly to our primal sense of pattern recognition. It was the detail that nobody could explain away, the shape. As the 3I Atlas Anomaly, account fed the analytical side of the investigation. A different kind of evidence was emerging from the global community of amateur astronomers. Working independently, from different continents, using different equipment, they all began to report the same surreal observation. When they processed their long exposure images, when they digitally subtracted the light from the background stars and enhanced the faint contrast of the object itself, what remained was not the fuzzy, irregular, chaotic blob you would expect from a comet with an active coma. What remained was something structured, something elongated, smooth, and almost geometric. It was, just as the UFO mania tweet had sensationally claimed, perfectly cylindrical. Now, in the pursuit of truth, skepticism is our most important tool. And a good scientist would immediately point out that such an elongation could be a trick of the light, a visual artifact. It could be caused by the object's motion across the frame during a long exposure, or by the complex way light scatters through its gassy coma. And those skeptics would be absolutely right. It can be an artifact. But here is the chilling counterpoint that hangs in the air. It can also be real. And how do we know this? We know this because we have seen this movie before. This isn't the first time a messenger from interstellar space has arrived at our door looking like nothing we expected. Do you remember Oumuamua? The very first interstellar visitor we ever detected. Scientists expected to find a roundish, tumbling space rock. Instead, what they found was an object so bizarre it shattered our paradigms. Some said it was shaped like a cigar. Others argued it was flat, like a pancake. But everyone agreed on what it was not. It was not round. It was not what we expected. It was elongated, geometric, strange. So when 3I Atlas, the next interstellar visitor to grace our skies, begins to show eerily similar characteristics, when multiple, independent observers all report the same geometric quality, and when the official channels that could confirm or deny these observations with crystal clear images remain stubbornly, unervingly silent, what are we supposed to think? When lightning strikes the same spot twice, you stop calling it a coincidence, and you start looking for a lightning rod. What is it about our solar system that seems to be attracting these strange, elongated visitors from the stars? The answer, according to NASA's carefully worded and surgically precise public statements, is that we shouldn't think too hard about it at all. Their official position? 3I Atlas poses no threat to Earth. They assure us its trajectory will keep it safely hundreds of millions of kilometers away. They tell us it will make its closest approach to the Sun on October 30th, and then continue on its long journey out of our solar system, never to return. And every single word of that statement is technically true, but it is also a masterclass in evasion. It answers the one question very few people were actually asking: is it going to hit us? While completely and utterly sidestepping the two questions that are screaming in the minds of everyone paying attention. What is it? And why, on the very day we should have gotten our best, clearest look at it, did 15,000 of your employees get sent home? The silence is no longer just an absence of data. It is a presence. It is a statement. And it is the most terrifying clue of all. To truly understand the story of 3I Atlas, we must be willing to journey to the very edge of what we consider to be evidence. We have followed the digital trail of data and the deafening silence of the world's space agencies. Now, we must turn to a different kind of instrument, one that is far more controversial, infinitely more mysterious, and yet, in this case, disturbingly prescient: the human mind itself. What I am about to tell you did not happen in an observatory or a laboratory. It happened in the quiet of a room, 2 months before the Mars flyby, before the viral posts, before the global panic, and before most of the world even knew 3I Atlas existed. And it happened under conditions so rigorous that they make it almost impossible to dismiss as mere wishful thinking. Her name is Birdie Jorsky, and in the small, often misunderstood world of professional remote viewing, her name carries the weight of authority. She is the former vice president of the renowned Farsight Institute, a practitioner with nearly 3 decades of experience, and she holds a master's degree in digital forensics. This is not the profile of someone chasing internet fame with wild, unsubstantiated claims. This is the profile of a meticulous investigator, albeit in a field that science has yet to fully embrace. In August of 2025, a friend and colleague gave her a target for a remote viewing session. It was just a string of numbers, a set of coordinates. There was no context, no photograph, no news article, no name. This is the bedrock of legitimate remote viewing protocol. The target must remain completely blind. The viewer must have absolutely no idea what they are looking at until after the session is complete, ensuring their perception is not colored by expectation or prior knowledge. Birdie sat down, entered her meditative protocol, and began to describe the impressions that were forming in her mind's eye. The very first thing she reported was movement. Something vast, ancient, and cold, traveling through the blackness of space. She described it as a natural object, icy and rocky. In every way, her initial perceptions were a perfect description of a comet. And for a while, that is all it was, a remarkably accurate, if mundane, remote viewing of a celestial body. But then, as she focused her perception deeper, she noticed something that didn't belong. There was something that was not completely natural, she would later recount in a podcast discussing her findings. She described the feeling as a subtle dissonance, a discordant note in a perfect cosmic symphony. It was like discovering a single modern fingerprint on the surface of a billion-year-old fossil. It was a signature where there should have been only randomness. She pushed her perception further, going deeper into the heart of the object, and that is when she saw it. Something small, incredibly small, considering the scale of the comet. It was about the size of a thumb drive, and it had not formed there. It had been placed there, deliberately, with intelligence and purpose. Someone had bored into this rock, she reported with a sense of awe. Bored into this icy rock deliberately, and placed something encoded with all kinds of information. She struggled for an analogy, something that could capture the sheer mind-bending reality of what she was perceiving. It's kind of like an archive, she concluded. A message in a bottle. But it's not just a message. It is technology of some sort. Pause for a moment and truly absorb what she is describing. This is not a grand alien mothership, not an invasion fleet. It is something far more subtle, more elegant, and in a way, more believable. A tiny piece of technology, ancient beyond our comprehension, hidden inside a natural object, using a comet as a vessel to travel through the galaxy for perhaps billions of years. She went on, her voice filled with a sense of profound antiquity. This thing is so old. And even though the object itself is like billions of years old, the thing that was placed inside of it is also very, very old. She then posed a question that sounds like it was lifted from the pages of the greatest science fiction. Did some species there on the other side of the galaxy send up a little robot to bore into it and stick their little message and technology, knowing that this thing was going to keep traveling? And before you dismiss that question as pure fantasy, remember this: we have done the exact same thing. The Voyager probes, launched in the 1970s and now drifting in interstellar space, each carry a golden record. These are time capsules, archives of our world's sights, sounds, and music, designed to survive for 1 billion years in the hope that someone, someday, might find them. The idea of using a vessel to carry a message across the cosmic ocean is not alien to us at all. We just never seriously considered that we might one day find a bottle that was ours washed up on our shore. Only after the session was complete, after every perception had been documented, did Birdie's friend reveal the identity of the blind target she had been viewing. 3I Atlas. She had perceived, in stunning detail, a technological component hidden inside an interstellar object that most of the world did not yet know existed. But she wasn't finished. In 2 more sessions, she went even deeper, and what she found next changed the entire picture. It is also broadcasting, she reported, and the tense of that verb is critical. She didn't say it was broadcasting billions of years ago. She said it is broadcasting right now. The message in the bottle isn't just floating. It's talking. It's sending out pulses of information into our solar system. When the podcast host mentioned that the renowned astronomer Avi Loeb had recently published calculations showing that 3I Atlas arrived from the same region of the sky as the famous WOW. Signal from 1977, Birdie didn't hesitate. "That is super interesting," she said. "It is very possible that that is the wow signal. Now, how much weight can we give to this testimony? It is not by any stretch of the imagination a conventional scientific method. Remote viewing cannot be easily replicated or verified in a lab. Skeptics rightly dismiss it. Believers swear by it. And the truth, as it so often does, probably lies somewhere in the complicated, uncomfortable middle. But here is what makes Birdie Jorski's account so compelling and impossible to ignore. She was not alone. In the months that followed, multiple other remote viewing groups, working independently with no contact with each other, also targeted 3I Atlas, and while the specific details of their perceptions varied, a core set of themes emerged again and again with eerie consistency: technology, deliberate placement, broadcasting, and the involvement of a non-human intelligence. One group reported perceiving humanoid forms associated with the object. Another described what they called graffiti, or signatures, as if its makers had signed their work. Several viewers reported the sensation that the object was being masked, deliberately trying to avoid full detection, as if it didn't want to be clearly seen. Does any of this prove that 3I Atlas is an alien probe? Of course not. These are not photographs or spectrographs. They are subjective impressions filtered through the complex lens of human consciousness. But they are also remarkably consistent, and they align in truly unsettling ways with the physical, measurable anomalies that our telescopes were just beginning to detect. Let's treat this not as proof, but as a hypothesis. If what Birdie Jorski perceived were true, if there were a small, dense, ancient piece of technology buried in the heart of this comet, what would we expect to see with our scientific instruments? We would expect it to look mostly like a comet, cloaked in ice and dust. But up close, we might notice things that don't quite fit. We might notice unusual chemical compositions, like nickel without iron. We would expect it to be far more massive than its visible size suggests, because there would be something dense and heavy at its core. And just maybe, if we pointed our radio telescopes in the right direction, we might detect something. A pulse, a pattern, a signal that shouldn't be there. Birdie Jorski described a message in a bottle traveling through the galaxy. And as our telescopes gathered more data, it began to look as though that bottle was glowing. October 8th, 2025. Mark that date in your mind. This was a day that should have gone down in the annals of science as a moment of historic revelation. It was the day humanity was scheduled to get its closest, most intimate look at an emissary from another star. Imagine the scene. High above the red desert of Mars, the Mars Reconnaissance Orbiter, a technological marvel, glides silently through the void. Its HiRISC camera, an instrument so powerful it can spot a beach ball from orbit, was positioned perfectly. Its lens was trained on a precise point in space, ready to capture images with a resolution 30 times better than anything the Hubble Space Telescope could ever hope to achieve. Standing by were the European Space Agency's Mars Express and ExoMars Trace Gas Orbiter, a fleet of humanity's best scientific instruments, all waiting, all watching. It was the astronomical equivalent of the Super Bowl, the Olympics, and a lunar landing all rolled into one. And then, at the exact moment when we needed our best players on the field, the entire team was sent to the locker room. 83% of NASA disappeared. 15,000 civil servants, the scientists, the engineers, the data analysts were furloughed. They were sent home right at the peak of what should have been the most intensive, exciting observation campaign in the history of interstellar astronomy. What was the official explanation for this baffling, seemingly self-sabotaging act? It was simple, mundane, and almost insultingly convenient. A federal government shutdown. A budget impasse in Washington, D.C., we were told. It had nothing to do with 3I Atlas. It was just, in the driest of bureaucratic terms, unfortunate timing. Unfortunate timing. Let those two words echo for a moment. Two words doing an incredible amount of heavy lifting to explain why the world's premier space agency went dark at the precise moment an object exhibiting 7.7 statistical impossibilities passed within a stone's throw of our most advanced cameras. Let's think about the odds of that. This wasn't a surprise event. 3I Atlas was discovered back in July. The Mars flyby was planned for months. Scientists around the globe knew this would be their one and only chance to capture high-resolution images before the object vanished behind the sun. NASA knew. The European Space Agency knew. Every space agency on Earth knew that this was the moment. And in the final, critical week leading up to the closest approach, the United States government shut down. NASA's official website stopped updating. Press releases ceased. The army of brilliant minds who should have been eagerly analyzing a flood of new data were told to turn off their computers and go home. Only a skeleton crew of essential personnel remained, maintaining only the most critical operations. But here is where the story turns from merely suspicious to deeply sinister. What exactly is considered essential? It turns out, collecting the data was deemed essential, but sharing it with the public was not. The raw image feeds from the Perseverance rover on the surface of Mars kept uploading. The rover didn't stop working. And high above, the Mars Reconnaissance Orbiter didn't stop working either. The cameras were active. The data was being collected. It was flowing from Mars to Earth into the deep archives of the Jet Propulsion Laboratory, where it was seen only by that skeleton crew. It just wasn't being released to you and me. As the official channels went dark, the global community of citizen scientists desperately tried to fill the void. A YouTuber with a solar telescope who goes by the name Dobsonian Power posted an image on October 8th with a simple, frantic caption. What on earth is it? The image, captured from his own backyard, showed something dark and angular, a strange, unnatural shape embedded within the fuzzy coma at the expected position of 3I Atlas. Within hours, the post exploded. Thousands of people demanded answers, all pointing out the obvious, infuriating irony. If a backyard observer could capture something this strange, what were the multi-billion-dollar professional instruments seeing? From NASA, there was only silence. From the European Space Agency, more silence. The only official confirmation that any observation had even occurred came not from an agency, but from the astrophotographer Simeon Schmoes, the man who had first stacked the Perseverance images. He posted his work on social media, a private citizen, doing the work that the world's governments would not. The pressure continued to build until it finally breached the walls of Washington, D.C. itself. At a White House press briefing, Stephen Miller, the Deputy Chief of Staff for Policy, was fielding questions about the government shutdown when a reporter asked a question that had been burning across the internet for days. Has the president been briefed about 3I Atlas? For a moment, the room went quiet. You could feel the air change. Miller paused, his face a mask of careful neutrality, and then he chose his words with surgical precision. He deflected, changed the subject, and the briefing moved on. But the question had been asked. On camera, in an official setting in the White House press room. It could no longer be dismissed as just another internet conspiracy. The United States government was being asked directly about this interstellar object, and they were actively choosing not to answer. Meanwhile, the astronomer Avi Loeb, a tenured Harvard professor, and one of the most vocal proponents of the idea that these objects could be extraterrestrial technology, was making the rounds on every news network that would listen. He went on Newsmax, on CBS, on podcasts, his voice a beacon of scientific reason in a sea of speculation. He laid out the anomalies with mathematical precision, the trajectory that was perfectly aligned with the plane of our solar system, a 0.2% probability, the timing that was perfectly optimized to encounter 3 different planets, a 0.005% probability, The 7 distinct characteristics that made 3I Atlas unlike any comet ever observed. And he kept returning to one single, crucial point. We need the Mars orbiter data. The high-RIC images, he argued, could resolve the nucleus. They could tell us its size, its shape, its structure. They could answer the fundamental question, what are we looking at? But the images, the very data that could end the debate, were being held under lock and key. The shutdown wasn't just unfortunate timing. It was the perfect smokescreen. It was the ultimate excuse to see everything and to show us nothing. In the world of science, there is a beautiful principle called Occam's razor. It's the idea that when you are faced with competing explanations for a phenomenon, the simplest one, the one with the fewest assumptions, is usually the correct one. It is a razor that shaves away complexity and reveals the elegant truth. One anomaly in the behavior of a comet can be explained away as a quirk of nature. 2 might be a fascinating coincidence. But what happens when you discover not 1, not 2, but 7 statistical impossibilities, all stacked on top of each other, all in the same object? At that point, Occam's razor begins to cut in a very different and much more unsettling direction. At what point does the simplest explanation stop being, it's a very, very, very strange comet, and start being, it's not a comet at all? Let me walk you through the 7 impossible things that are keeping astronomers awake at night. The 7 characteristics that make 3I Atlas unlike anything we have ever tracked through our solar system. Anomaly number 1, the mass problem. When astronomers first detected 3I Atlas, they calculated its size based on a simple factor, its brightness. By measuring how much sunlight it reflected, they got a number that made absolutely no sense. For the object to be that bright, it would have to be enormous, somewhere between 10 and 20 kilometers across. To put that into perspective, our first interstellar visitor, Oumuamua, was barely 100 meters long. The second, 2I Borisov, was less than a kilometer. This new object, 3I Atlas, appeared to be orders of magnitude larger. Now, our statistical models are very clear about what we should expect to find drifting between the stars. Small objects should be incredibly common. Large objects should be exceedingly rare. Based on the models, we should have found hundreds, maybe even thousands, of Oumuamua-sized visitors before we ever stumbled across something as gigantic as 3I Atlas. The probability of our third interstellar detection being this massive was calculated at roughly 0.01%. That's a 1 in 10,000 long shot. It was like going fishing in a pond full of minnows and pulling out a blue whale on your third cast. But the mystery didn't stop there. As observatories around the world tracked the object, they gathered over 4,000 precise measurements of its position. When scientists analyzed this data, they compared its actual trajectory to a path dictated purely by gravity. They were looking for a tiny deviation, a slight wobble caused by the comet's outgassing, the jets of gas and dust erupting from its surface that should act like tiny rocket thrusters, pushing it off course. What they found was remarkable. There was almost no deviation at all. Despite losing an estimated 150 kilograms of material every single second, the object barely budged from its path. This implies that the nucleus is unimaginably massive, so heavy that even these constant, powerful jets cannot push it off course. The new calculations suggested a nucleus larger than 5 kilometers in diameter, with a mass of more than 33 billion tons. That makes it roughly 1 million times more massive than Oumuamua. 1 million times. Think about that staggering gap. It's the difference between a single grain of sand and a 10-pound boulder. Anomaly number 2, the sunward glow. On July 21, 2025, the Hubble Space Telescope captured the highest resolution image of 3I Atlas we had at the time. And in that image, scientists noticed something that had never been documented in any comet, ever. The coma, the fuzzy cloud of scattered light around the nucleus, extended roughly twice as far toward the sun as it did in any other direction. Now, this violates one of the most basic principles of cometary physics, something we've confirmed with thousands of observations over centuries. Comets have tails that point away from the sun. Why? Because the sun's radiation physically pushes the dust particles outward. It's a fundamental law. Yet 3I Atlas seemed to have a tail that pointed the wrong way. The extension wasn't subtle. It was a 10-to-1 ratio of brightness. Avi Loeb and his colleague published a paper trying to explain this, suggesting a complex model involving large ice fragments that sublimate at different rates. The physics was sound, the math checked out, but it required a very specific, unique set of conditions that had never been observed before. It was another case of special pleading, another instance of 3I Atlas being a 1-in-a-million special snowflake. Anomaly number 3, the industrial fingerprint. In late August, the Very Large Telescope in Chile, one of the most powerful observatories on Earth, trained its spectrograph on 3I Atlas. It broke the light from the comet's coma down into its chemical components, like a prism, and detected something that stopped scientists in their tracks. It found nickel atoms in the gas plume. Lots of nickel, with the amount increasing exponentially as the object got closer to the sun. But here is the problem. They detected almost no iron. In nature, nickel and iron are cosmic twins, born together in the fiery death of stars. They occur in roughly fixed ratios in every natural object we've ever studied. Every comet from our solar system has normal nickel-to-iron ratios. The previous interstellar comet, 2I Borisov, had a normal ratio, but 3I Atlas was producing nickel without its twin. Where is the only place we see that signature? In industrial production. In nickel alloys, in materials that have been deliberately refined and separated by technology. The scientists who published the data called it extremely puzzling, noting that the temperatures were far too low to vaporize the minerals that contain these metals. You could feel the bewilderment right through the cautious scientific prose. It was a chemical signature that simply shouldn't exist in nature. It was the fingerprint of a factory, found in the middle of a pristine wilderness. As we continue our descent into the rabbit hole of D Atlas, the anomalies begin to compound, shifting from mere curiosities to a pattern of profound strangeness. We've seen an object with impossible mass, a tail that defies physics, and a chemical signature that whispers of industrial refinement. Now, we must add 4 more layers to this cosmic enigma, 4 more statistical longshots that, when combined, stretch the definition of coincidence to its absolute breaking point. Anomaly number 4, polarization from another world. We've already touched on the strange polarization signature of 3I Atlas, but it's worth diving deeper into just how bizarre this measurement truly is. When sunlight, which is unpolarized, bounces off the dust particles in a comet's coma, it becomes polarized. The angle and degree of this polarization are like a secret code that tells scientists about the nature of those dust particles, their size, their shape, their composition. We have built vast catalogs, libraries of polarization data from hundreds of comets and asteroids. We know the patterns. We know what a normal comet looks like. 3I Atlas showed a polarization signature that simply does not exist in any of those catalogs. Its specific combination of measurements, a negative polarization of minus 2.77% at a phase angle of around 7 degrees, and an inversion angle of only 17 degrees, had never been seen before. Not once. The closest match scientists could find wasn't with comets at all, but with a strange class of icy bodies from the extreme outer reaches of our solar system, like trans-Neptunian objects, and a specific centaur named Pholus. These are objects with very different compositions and histories than typical comets. It was like finding a polar bear in the middle of the Sahara Desert. It doesn't mean it's impossible, but it demands an extraordinary explanation for how it got there. A paper submitted to the prestigious astrophysical journal Letters concluded, with careful scientific understatement, that 3I Atlas may represent a distinct type of comet. Distinct type is the polite, scientific way of saying, we have no category for this. It has broken our model. Anomaly number 5, the ecliptic alignment. Our solar system is, for the most part, flat. The planets all orbit the sun in a relatively thin plane, like marbles rolling on a dinner plate. This is called the ecliptic plane. Now, objects arriving from interstellar space should come from completely random directions. Imagine our solar system as that dinner plate and interstellar visitors as gnats flying through the room. They could cross the plate from above, from below, or at any random steep angle. The probability of one of these interstellar gnats happening to fly perfectly parallel to the surface of the plate is incredibly low. To be precise, the probability of an interstellar visitor as orbit aligning within 5 degrees of our ecliptic plane is roughly 0.2%. That is a 1 in 500 chance. And yet, 3I Atlas arrived, aligned almost perfectly with our solar system's plane. Not only that, but it is moving retrograde opposite to the direction that all the planets orbit. Why is this significant? Because this is the absolute ideal trajectory you would choose if you were designing an interplanetary reconnaissance mission. It allows you to survey multiple planets with the absolute minimum amount of fuel and course corrections. It's the scenic route, the grand tour, and 3I Atlas just happened to stumble onto it by chance. Anomaly number 6, the planetary timing. This brings us to an even more staggering improbability. As 3I Atlas sails through our solar system on this perfectly aligned trajectory, it will pass remarkably close to 3 different planets. It flew by Mars at just 0.19 astronomical units. An astronomical unit, or OA, is the distance from the Earth to the Sun. It will also have close encounters with Venus and Jupiter. Now, what is the probability of a random interstellar visitor arriving with timing so exquisitely perfect that it allows for close approaches to 3 different planets in a single pass? According to the calculations, that probability is approximately 0.005%. Let me say that again, 0.005%. That is a 1 in 20,000 chance. It is the astronomical equivalent of winning the lottery. If you were a non-human intelligence designing a probe to fly through our solar system and gather as much data as possible, this is the exact trajectory you would painstakingly calculate and execute. To believe this is a coincidence is to believe in a miracle of celestial mechanics. Anomaly number 7, the WOW, signal coincidence. Our final anomaly takes us back in time to a single, tantalizing moment in 1977. At the Big Ear Radio Telescope in Ohio, a signal was detected that was so unusual, so powerful, and so clearly artificial that the astronomer on duty, Jerry Emmon, simply scribbled the word "wow" in the margin of the data printout. It came from the constellation Sagittarius, lasted for exactly 72 seconds, and has never, ever been detected again, despite decades of searching. It remains the most compelling potential evidence of extraterrestrial intelligence ever recorded. Now, what does this have to do with 3I Atlas? When scientists traced the trajectory of 3I Atlas backward through the galaxy, accounting for its speed and direction, they calculated where it would have been in the year 1977. The answer is chilling. It was within just 9 degrees of the origin point of the WOW signal. The probability of this alignment being a pure coincidence is roughly 0.6%. So let's take a step back and look at the full picture. We have an object that is 1 million times more massive than expected. It has a tail that points the wrong way. It's producing industrial byproducts. Its dust is unlike anything we've ever seen. It arrived on a 1 in 500 trajectory. Its timing allowed for a 1 in 20,000 planetary trifecta, and it came from the exact direction of the most famous potential alien signal in history. 7 anomalies. 7 statistical longshots. And we are being asked by the official authorities to believe that they are all just a string of incredible coincidences, all happening in the same object at the same time. At what point does Occam's razor, the principle of simplicity, compel us to consider the alternative? That this is not a coincidence at all, that this is a pattern, that this is a sign of design. Right now, as you are reading these words, as the world debates and the silence from NASA deafens, 3I Atlas is on a journey into darkness. It is somewhere we cannot see it, hidden in the blinding glare of the sun, moving inexorably toward a point in space where the universe strips away all pretense and physics becomes brutally, beautifully honest. This point is called perihelion, the moment of closest approach to our star. For 3I Atlas, that moment of truth will arrive on October 29th, 2025. It will pass just inside the orbit of Mars, at a distance where the sun ceases to be a distant, benevolent light source and becomes an overwhelming, all-consuming presence. Imagine standing directly in front of an open blast furnace. Now, multiply that ferocious heat by a factor you cannot possibly comprehend. That is what perihelion means for an object that has spent billions of years in the frozen, abyssal darkness of interstellar space. Sunlight, raw and unfiltered, will pound its surface with gigawatts of power. And that's not a metaphor. We're talking about actual, measurable watts, the kind of energy that powers our cities, all focused on this single, enigmatic object. The astronomer Avi Loeb, in one of his many poignant observations, made a comment that has stuck with a lot of people. He said, high-stress environments elicit confessions. He was talking about interrogation tactics, but the principle applies with perfect, unforgiving clarity to physics as well. When you put something under extreme stress, it cannot hide its true nature. When you heat ice, it cannot pretend to be anything other than water vapor. When you heat rock, it behaves like rock. And when you heat something that is pretending to be a comet, but might just be something else entirely, the mask is ripped away. October 29th is the day 3I Atlas will be forced to confess what it really is. And as we stand here, blind and waiting, there are two starkly different scenarios for what that confession might be. They could not be more different, and one of them has the potential to change the course of human history. Scenario 1. The natural spectacle. In this scenario, 3I Atlas is exactly what it appears to be on the surface. A comet. An unusually massive, chemically bizarre, statistically improbable comet, to be sure, but a natural object nonetheless. If this is the case, then October 29th will mark the beginning of one of the most spectacular celestial shows we have ever witnessed. As the surface temperature skyrockets, volatile elements that have been locked in a deep freeze for billions of years will suddenly, violently, awaken. Carbon dioxide will sublimate directly into gas. Water ice will flash into vapor. Dust particles, ancient and pristine, will lift off in enormous billowing plumes. We have seen this happen before. Comets near perihelion become magnificent, almost mythic beasts. They develop tails that can stretch for millions of kilometers. They brighten dramatically, sometimes by a factor of 10 or more. And sometimes, under the immense gravitational and thermal stress, they even fragment, breaking apart into a cascade of smaller pieces that eventually disperse into a shimmering trail of cosmic dust. It is a process that is violent, chaotic, and utterly, breathtakingly beautiful. If 3I Atlas is natural, we should see something similar. We should see a massive outburst of gas and dust. We should see its brightness increase exponentially. We should see it develop a proper, classic cometary tail, not the anomalous sunward glow, but a majestic plume streaming behind it as the sun's radiation pressure finally does its work. And if the object is as fragile as some scientists suspect, if that 5-kilometer diameter is mostly loosely bound ice and dust rather than solid rock, perihelion might be the end of its journey. The gravitational pull of the sun might tear it apart entirely. We could watch, in real time, as an interstellar visitor from another star system disintegrates before our very eyes. And while that might sound like a tragic end, it would be an absolute bonanza for science. It would give us an unprecedented, intimate look at the internal structure and composition of a comet that formed around another star. It would answer fundamental questions about how planetary systems are built, about the chemistry of worlds beyond our own. It would be an extraordinary, if destructive, scientific gift. But then there is the other possibility. Scenario 2, the activation. In this scenario, 3I Atlas is not natural. The 7 anomalies are not a string of coincidences. They are a pattern of intent. The nickel without iron, the backward tail, the perfect alignment with our solar system's plane, and the wow, signals origin, they all mean something. They are clues deliberately left, or perhaps just inherent properties of something that was built. In this scenario, perihelion is not about sublimation. It is about activation. Think about it logically. If you were an advanced intelligence and you wanted to send a probe to another star system, how would you design it? You would need it to survive a journey of unimaginable length and hardship. Billions of years in the crushing cold, bombarded by cosmic radiation, peppered with micrometeorite impacts. What is the perfect camouflage? What is the perfect shield? Ice. Ice is abundant throughout the universe. It's an incredible insulator. And most importantly, it makes your probe look completely natural to any emerging civilization that might spot it before it is ready to be noticed. But once that probe reaches its destination, once it enters the inner solar system and approaches the host star, it needs to do 2 things. It needs to wake up, and it needs power. And in the vast emptiness of a solar system, there is only one power source worth tapping, the star itself. Perihelion, in this scenario, is not a stress test. It is a charging station. It is a moment of activation. And the confession it makes might not be one of dust and gas, but one of purpose and intent. And we, hidden behind the sun, will be completely unable to see it happen. In his papers, Avi Loeb, with the dispassionate precision of a physicist, laid out the chilling possibilities of what activation might actually look like. This wasn't wild speculation. It was an exploration of applied physics, of real-world techniques that we ourselves have used. The first possibility is something called a solar Oberth maneuver. This is a very real and incredibly efficient technique used by our own spacecraft to navigate the solar system. Imagine a spacecraft on a swing. To get the biggest push, you don't kick your legs in the middle of the arc. You kick at the very bottom, at the point of maximum speed. The Oberth maneuver works on the same principle. You dive as close to a massive gravitational body like the sun as you possibly can. Then, at the point of your highest velocity, you fire your engines. The resulting change in your trajectory is exponentially greater than it would be if you fired your engines in the slowness of deep space. It is by far the most fuel-efficient way to make a dramatic change in your course. Now, consider the facts. The optimal point for executing an Oberth maneuver is at perihelion, the point of closest approach and maximum speed. And where will 3I Atlas be when it reaches perihelion? It will be completely obscured from every single Earth-based observatory, perfectly hidden behind the sun. If an object wanted to change its course, to alter its destiny without being detected, this would be the absolute perfect moment to do it. It could fire an engine, deploy a solar sail, or use some other form of propulsion we can't even imagine, and we would be utterly blind to it until it was too late. Or, perhaps, the activation could be something even more subtle and strategic. The object itself might not need to change course. Instead, it could release something. Smaller probes, mini-craft, that detach from the mothership and use the object's incredible velocity and retrograde trajectory to intercept planets. From its position at perihelion, Mars, Earth, and even Jupiter are all easily reachable with minimal course corrections. The exquisitely precise timing of the planetary alignments that we dismissed as a 1 in 20,000 coincidence suddenly looks less like a fluke and more like a flight plan. The comet isn't the messenger. The comet is the delivery truck. Avi Loeb, never one for hyperbole, was careful to note the profound and terrifying implications of such a scenario. He wrote that if 3I Atlas were to maneuver towards Earth when it reappears on the other side of the sun, the financial markets may crash. That is not an exaggeration. That is a sober, rational assessment of what happens to human civilization when it is suddenly and unambiguously confronted with the reality that we are not alone, and that the visitors might not have come in peace. But for now, we will not know. We cannot know. Because between now and early December, we are flying blind. Every telescope on Earth, every space-based observatory in orbit around our planet, is effectively useless for observing 3I Atlas. It is in a perfect communication blackout, a cosmic dead zone that would be the ideal cover for a spacecraft that did not want to advertise its next move. But humanity is not entirely without a spy in the void. There is a contingency plan. The European Space Agency, in a move of brilliant foresight, has a spacecraft in the right place at the right time. Between November 2nd and November 25th, the Jupiter Icy Moons Explorer, a probe currently on its long journey to Jupiter, will turn its powerful instruments away from its destination and toward the position where 3I Atlas should be. This spacecraft, known as JUICE, will catch the object just after its perihelion passage. It will be our first witness after the interrogation. It will see what 3I Atlas confesses. JUICE was not designed to study comets. Its cameras and spectrometers are optimized for the icy moons of Jupiter, for detecting subsurface oceans, for analyzing the chemistry of alien water. But those same instruments are more than capable of looking at 3I Atlas. And because JUICE is currently located between the Earth and the Sun, it has a unique viewing angle. It can see into the Sun's glare in a way that we, from our terrestrial vantage point, simply cannot. If the object develops a massive coal mine tail, as a natural comet should, JUICE will see it. If it fragments and breaks apart under the strain, JUICE will document the debris field. And if it does something else, if it maneuvers, if it releases smaller objects, if it exhibits any behavior whatsoever that is inconsistent with a natural comet, JUICE will record that too. The data will not be instantaneous. Communicating across hundreds of millions of kilometers of space takes time, and JUICE is very far from home. But by late November or early December, we should begin to get answers. And that timing is critical, because it is the exact same time that 3I Atlas will finally re-emerge from behind the sun and into the view of our telescopes on Earth. December 19th is the date to circle on your calendar. That is when the object will make its closest approach to our planet. It will still be a very safe 1.8 astronomical units away. That's about 270 million kilometers. So there's absolutely no threat of impact. But it will be close enough for every major observatory on the planet to be watching. It will be close enough for us to track its trajectory with extreme, unforgiving precision. And that is when we will know if anything changed during its time in the dark. If its orbit is exactly as predicted by our gravitational models, then we can all breathe a collective sigh of relief. It was just another interstellar visitor, strange and beautiful, but natural, passing through on its long way back to the cosmic dark. But if the numbers are off, if the trajectory shows even the slightest deviation that cannot be explained by outgassing or the gentle push of solar radiation, then every single assumption we have ever made about our place in the universe will need to be thrown out the window. October 29th is the day 3I Atlas confesses what it really is. Except we, the jury, will not be able to hear that confession until December. And by then, it might be too late to do anything but watch what happens next. While scientists in quiet observatories debated spectrographs and orbital mechanics, and NASA officials maintained their stoic, impenetrable silence. Something else was happening. A parallel story was unfolding, one that moved not at the speed of light, but at the speed of a share. The internet was catching fire. A global panic, a digital pandemic of fear and fascination, was beginning to spread, mutating and evolving as it crossed borders and languages. It started, as these things so often do, in the United States. On platforms like TikTok, videos began to appear, showing alleged images of 3I Atlas. Some were genuine, enhanced amateur shots. Most were fakes, digitally altered to look more dramatic, more alien. But real or fake, it didn't matter. They all accumulated millions of views. On Reddit, sprawling threads and forums dedicated to astronomy, UFOs, and conspiracy theories ballooned into thousands of comments. A chaotic mix of brilliant analysis, wild speculation, and genuine fear. Twitter, or X as it is now called, became a digital battleground. On one side were the amateur astronomers, diligently posting their legitimate observations and data. On the other were the influencers and engagement chasers, posting increasingly outlandish claims, knowing that fear and wonder are the most viral of all human emotions. But America was just the epicenter. The shockwaves quickly spread globally, and in India, the story mutated into something altogether different and far more potent. On WhatsApp, the primary communication tool for hundreds of millions of people, rumors began to travel faster than any fact-checker could ever hope to respond. Urgent, breathless forwards, written in Hindi, described an alien ship in disguise, a wolf in sheep's clothing. Videos, narrated with voices of grave authority, claimed the object was already changing course, heading for Earth. Screenshots of fake news articles, with headlines designed to terrify, went viral. World governments in secret. Negotiation with 3I Atlas occupants. Military forces mobilized for first contact. A third, particularly insidious forward, showed an edited image purporting to be a leaked NASA document, stamped Classified, showing a clear, geometric structure where the comet's nucleus should be. None of it was true. All of it spread like wildfire. Hindi-language YouTube channels exploded with content. Some were earnest, noble attempts at science communication, calmly explaining what an interstellar object actually was. But many others leaned hard into speculation, skillfully blending legitimate astronomical facts with ancient astronaut theories, Vedic prophecies, and doomsday predictions. The line between education and entertainment, between science and scripture, blurred until it vanished entirely. In Brazil, a similar dynamic played out on Telegram and Facebook. Brazil has a uniquely vibrant and complex ecosystem of conspiracy theories, one that blends indigenous mythology, Catholic mysticism, and modern UFO lore into something that defies easy categorization. For these communities, 3I Atlas became a cosmic Rorschach test. It was everything to everyone. To some, it was a harbinger of the apocalypse, a sign from the heavens. To others, it was a vessel of enlightened beings, come to save humanity from its own self-destructive tendencies. It was a weapon. It was a gift. It was a test. Facebook groups dedicated to the object swelled with tens of thousands of new members overnight. Live streams, hosted by charismatic local personalities, ran for hours with hosts reading complex scientific papers aloud and then immediately pivoting to the wildest possible speculation, far beyond anything the papers claimed. The comment sections of these streams were like digital campfires, where thousands gathered to share their fears, their hopes, and their theories in a torrent of digital emotion. The United Kingdom, with its long and storied history of crop circles and Ministry of Defense UFO investigations, approached the mystery with a characteristic mixture of wry skepticism and deep intrigue. The British tabloids, masters of the sensational headline, walked a careful line between outright fantasy and plausible deniability. Massive comet could be alien tech, scientists say, one headline screamed. The scientists in question were usually just Avi Loeb, his cautious academic words often quoted out of context to sound far more alarming. But the headlines did their work, planting a seed of doubt and wonder in the public consciousness. Russia, predictably, saw the entire phenomenon through a geopolitical lens. State-controlled media mentioned the object only in passing, but always took care to note the American uncertainty and confusion. Some commentators suggested that Western powers were manufacturing a crisis, creating a phantom menace to justify a massive increase in military spending. Others hinted darkly that the United States government knew far more than it was saying, perhaps even that American black budget programs had already made contact. On Russian-language forums, the level of astronomical and technical discussion was often impressively high, a testament to the country's deep scientific heritage. But mixed in with the legitimate science were threads of paranoia, with users suggesting 3i Atlas was somehow connected to secret Soviet-era space programs, recovered alien technology, or ancient conspiracies stretching back to the Cold War. And then came the Michio Kaku incident, a perfect case study in how modern disinformation works. A screenshot began circulating, showing the world-renowned theoretical physicist in what appeared to be a television interview. A text overlay, designed to look like a news channel's graphic, quoted him as stating that 3i Atlas was on its way to conduct a reconnaissance mission, possibly with hostile intent. The caption read, "It might be an alien probe sent to Earth. The image was real. Kaku is a frequent guest on news programs." But the context was a complete fabrication. Fact-checkers quickly traced the screenshot back to a News Nation interview from February 2025, months before 3i Atlas was even discovered. Kaku had been discussing a completely different topic, most likely a hypothetical asteroid impact scenario. Someone had lifted his image, added the false, terrifying text, and released it into the wild. It didn't matter that it was a lie. The post accumulated over 290,000 views before social media platforms even began to flag it as false. By then, the damage was done. The image had been screenshotted and reshared countless times, each iteration making it harder to trace back to the original lie. The account that posted it never issued a correction. Thousands of people around the world now believed, with absolute certainty, that one of the most respected physicists on the planet had confirmed that a hostile alien probe was on its way. The global panic had found its celebrity endorsement. As the global firestorm of speculation and disinformation raged, the very institutions we rely on for clarity and truth seemed paralyzed, their voices reduced to a whisper against a hurricane. NASA, the agency at the heart of the mystery, finally tried to respond. On September 30th, their official solar system social media account posted a single stark message. It read, "Comet 3i Atlas poses no threat to Earth. It will remain hundreds of millions of kilometers away from our planet. This is a natural interstellar object, extremely rare and scientifically valuable, but not dangerous." The statement was factually correct, concise, and utterly, completely useless. It was like trying to put out a forest fire with a water pistol. The response from the public was immediate, ferocious, and deeply skeptical. Thousands of replies flooded in, all asking the same obvious questions. If it's just a comet, why did you shut down? If it's not dangerous, why the deafening silence? If it's natural, then explain the nickel without the iron. Explain the backward tail. Explain the 7 anomalies. NASA, following what appeared to be a strict protocol, did not engage further. The statement stood alone, a single sterile tweet against a tsunami of legitimate questions and wild speculation. It did nothing to calm the waters. In fact, it only made the agency seem more secretive, more evasive, as if they were hiding behind a shield of carefully worded non-denials. In the Middle East, Al Jazeera's highly respected fact-checking agency, SANID, published a thorough professional investigation. They confirmed that 3I Atlas was real. Discovered by the Atlas telescope on July 1, 2025, they independently verified its trajectory, confirming that its closest approach to Earth would be a very safe 270 million kilometers. They meticulously debunked the fake Michio Kaku quotes, the rumors of military mobilization, and the whispers of secret negotiations with extraterrestrials. Their report was a model of solid, responsible journalism. It was well-researched, clearly written, and it probably changed almost no one's mind. Because while Sanad was calmly checking the facts, Avi Loeb was taking the argument to a much higher and much more influential arena, the United Nations. Now, he wasn't addressing the General Assembly from the main podium. His work was quieter, more strategic, but potentially far more impactful. He was having conversations with delegates in the hallways. He was circulating his scientific papers among policy advisors. He was holding quiet meetings in back rooms where the phrase existential risk gets used without a trace of irony. He was presenting what he called his black swan event scenario. The concept of a black swan, developed by the philosopher Nassim Taleb, describes an event that is considered impossible until it happens, at which point it suddenly seems obvious and inevitable in retrospect. The 2008 financial crash was a black swan event. The rise of the internet was a black swan event. And Loeb was now applying this powerful concept to our search for extraterrestrial intelligence. He argued that we assume all interstellar visitors are natural, rocky comets because, for the first two we saw, that's what they were. We have built our entire scientific and psychological framework on a data set of two. But what happens, he asked the world's diplomats, when that assumption breaks? What happens when the third visitor is the black swan? Low probability, high impact events, he argued, require preparation, especially when we think they're unlikely. You don't buy fire insurance after your house has already burned down. As these high-level conversations were happening, a new hashtag began to trend, not on the mainstream feeds, but in the dedicated, obsessive online communities that were tracking 3I Atlas 24/7s. The hashtag was #the Harbinger. The term was drawn from ancient texts, from myths and prophecies and cultures all over the world that describe messengers from the sky harbingers of great change, of divine judgment, of a profound transformation of the human condition. Some people took it literally. The complex theology of the end times, it turned out, mapped surprisingly well onto the story of an interstellar object exhibiting 7 impossible characteristics and arriving at a time of global turmoil. Others used the term more metaphorically. For them, 3I Atlas was a harbinger of a new space age, a catalyst that would finally force humanity to awaken to the reality that we live in a universe that is far more crowded and far more mysterious than we have ever allowed ourselves to imagine. And through it all, through the panic, the speculation, the fact checks, and the prophecies, one name kept reappearing, a ghost in the digital machine. It was the name of Stephen Burns, the cosmologist who had been mentioned by the ex-BBC journalist Money Penny. The claim that he believed 3I Atlas was intelligent, that it exhibited a form of consciousness, and that it was already communicating with us, had taken on a life of its own. It circulated and recirculated, becoming an article of faith in the online communities. The strange thing was, no one could actually find the source. There were no published papers from Burns on the subject, no recorded interviews, no official statements. There were only these second-hand reports and cryptic social media posts. He was a scientific phantom, a name without a voice. But the idea he supposedly championed had stuck, because it fit too well with everything else that was happening. It resonated with a deep, unsettling feeling that something profound was unfolding, just beyond the edge of our perception, just beyond our ability to see it clearly. The anomalies, the silence, the global panic, they were all pointing toward the same incredible possibility. And the idea of a conscious, communicating object was the one theory that seemed to connect all the dots. And so we wait. Humanity holds its collective breath as 3I Atlas completes its silent, invisible passage behind the sun. But this period of blindness will not last forever. In early December of 2025, like a swimmer surfacing after a long and perilous dive, the object will emerge from the sun's glare. Astronomers will first find it in the pre-dawn hours, low on the eastern horizon, a faint smudge of light in the constellation Virgo. It will likely be around magnitude 12 or 13, still far too faint for the naked eye, or even for most amateur telescopes, but a perfectly clear and attainable target for the world's professional observatories. And at that moment, every single one of them will be watching. But they won't be looking for a beautiful picture. They will be looking at the numbers. Orbital mechanics is one of the most precise and unforgiving sciences we have ever developed. The laws of gravity, first laid out by Newton and later refined by Einstein, allow us to predict the position of a celestial object years, even decades, in advance, often down to the accuracy of a single kilometer. We can account for the subtle gravitational tugs from every planet in the solar system. We can calculate the gentle, persistent push of solar radiation pressure. We can even model the slight, chaotic thrust provided by the outgassing of a comet's own material. Our models are incredibly, exquisitely precise. When 3I Atlas reappears, its position on the sky will tell a story. It will be a final, unambiguous testament to what happened during its time in the dark. If its position is exactly where our pure gravitational calculations say it should be, give or take the tiny, expected deviation from outgassing, then we can reasonably and confidently conclude that nothing unusual happened. It endured its fiery trial by perihelion, it survived the heat, and it continued, unperturbed, on its long, predetermined path back into the outer solar system, and eventually back into the lonely darkness of interstellar space. The mystery will remain, but the threat, real or imagined, will have passed. But the position is off. If the trajectory shows changes, however slight, that cannot be explained by any of the known natural forces, then every scientific paper ever written about this object will need a dramatic, world-changing addendum. Every assumption will crack wide open. Because in the sterile, unforgiving logic of celestial mechanics, objects do not just change course on their own. Something has to push them. And if the sun's gravity and the comet's own outgassing cannot account for that push, then we will be forced to confront the only remaining possibility, that the push came from within, that it was a deliberate, controlled, and intelligent act. A brand new observatory will play a crucial, starring role in what happens next. The Vera Rubin Observatory in Chile, which has only recently become fully operational, represents a complete revolution in how we survey the sky. It is a fire hose of cosmic data. To give you a sense of its power, previous asteroid surveys, run over decades, found around 20,000 new objects per year. In its first 10 hours of operation, the Vera Rubin Observatory found 2,114 new asteroids. 10 hours, over 2,000 asteroids. The implications of this are simply staggering. When this new astronomical powerhouse turns its full attention to searching for interstellar objects, the current trickle of one visitor every few years will become a flood. Scientists estimate that we could be detecting dozens, perhaps even hundreds, of interstellar visitors every single year. And each new one we find will be studied with the hard-won lessons learned from 3I Atlas fresh in our minds. We will know exactly what to look for. We will immediately check for the strange chemical signatures, the anomalous polarization characteristics, the improbable trajectory alignments. If 3I Atlas is truly a one-of-a-kind artificial object, we will soon have a vast catalog of normal interstellar comets to compare it against, highlighting its uniqueness. If, on the other hand, it turns out to be the first of a whole new category of natural object, the Vera Rubin Observatory will find its siblings, and we will begin to build a new understanding of the universe. But December is not just about orbital mechanics and future surveys. It is about demanding answers to the questions that have been haunting us since July. What did the Mars orbiters actually see? By December, the politically motivated government shutdown will be a distant memory. NASA will be back at full staff. And somewhere, in a secure server room at the Jet Propulsion Laboratory, the high-RIC images from October 8th will have been processed, analyzed, and either locked away in a deep digital vault or prepared for public release. Those images, taken when 3I Atlas was just 29 million kilometers from the camera, have the potential to resolve features on the nucleus itself if the coma wasn't too dense. A 5-kilometer wide object at that range should show structure. We should be able to see its gross morphology. Is it round? Is it elongated? Is it an irregular potato-shaped rock? Or is it something else? The fact that these images have been so jealously guarded under the convenient cover of a shutdown raises questions that will not go away just because the calendar turns. In the hyper-competitive world of science, data this revolutionary is usually published as quickly as possible. The fact that multiple space agencies from multiple countries all observed 3I Atlas at Mars, and yet none have released detailed imagery, suggests one of two things. Either they are engaged in a massive, unprecedented, and highly unlikely global conspiracy of silence, or what they saw was so profound, so paradigm-shattering, that it requires the most careful consideration before being revealed to the public. December will force a reckoning on this silence. Either the images will finally emerge and confirm it's just a very strange comet, or the continued absence of those images will become its own terrifying answer. As the world's optical telescopes prepare to track the trajectory of 3I Atlas in December, another set of instruments will be listening with equal, if not greater, intensity. These are the giant silent dishes of our radio observatories, and they will be focused on a single, haunting question. Is the WOW signal connection a mere coincidence? Or is it the key that unlocks this entire mystery? If 3I Atlas was indeed the source of that enigmatic signal back in 1977, and if it is still capable of transmitting, then December will provide another golden opportunity to detect something. This won't be a new endeavor. For months now, multiple radio telescopes around the globe have been quietly monitoring the region of space where 3I Atlas is predicted to be. This isn't being done with the fanfare of the usual SETI, Search for Extraterrestrial Intelligence campaigns, which often involve press releases and public participation. This is a quieter, more patient, and perhaps more serious observation. They are simply listening, logging terabytes of cosmic static in the hope of finding a single, coherent signal, a whisper of artificiality in the natural roar of the universe. Any pulse, any pattern, any repeating signal in the radio frequencies that correlates perfectly with the object's known position would be, without exaggeration, the single most revolutionary discovery in human history. There is a very specific frequency they will be watching, 1420 megahertz. This is known to astronomers as the hydrogen line. It is the natural frequency at which neutral hydrogen atoms, the most common element in the universe, emit radio waves. This frequency is a universal constant, a cosmic signpost that would be known to any technological civilization, no matter how different from us they might be. It is for this reason that scientists have long called the hydrogen line the water hole, the quiet, obvious place in the vast radio spectrum where different species might gather to talk. And it is at precisely this frequency, 1420 megahertz, that the WOW signal appeared. If 3I Atlas has something to say, that is where it will most likely say it. December 19th, the date of the object's closest approach to Earth, will be a particularly crucial moment for these observations. While 270 million kilometers is a vast distance, it is close enough that parallax becomes a significant and incredibly useful tool. Parallax is the apparent shift in an object's position when you view it from two different locations. You can see this effect for yourself right now. Hold your thumb out at arm's length and close one eye, then the other. Your thumb will appear to jump back and forth against the background. That's parallax. By having observatories on opposite sides of the Earth, say, in Chile and in Hawaii, observe 3-eye atlas at the same time, we can use this parallax effect to triangulate its exact distance and velocity with breathtaking precision. Any deviation from the expected values, any sign of a trajectory that isn't purely gravitational, will become immediately, glaringly obvious. This global network of observatories, both optical and radio, northern and southern hemispheres, will provide round-the-clock coverage. It will be one of the most thoroughly documented, intensely scrutinized observations of any object in the history of our solar system. And somewhere in that mountain of data, in the precise measurements of its position, in the subtle shifts of its chemical signature, in the faint static of its radio emissions, we will find either confirmation or contradiction. We will find confirmation that this is, despite all the strangeness, a natural object from interstellar space. An ambassador from another planetary system, exhibiting rare but ultimately explainable characteristics. It is strange, perhaps, because it formed under completely different conditions than the comets in our own solar system. But it is ultimately and comfortingly following the same universal laws of physics that govern everything else. Or we will find contradiction, a data point that breaks the model, something in the trajectory, the chemistry, or the radio signals that simply cannot be reconciled with natural origins. A piece of evidence that forces us, as a species, to finally consider the possibility we have so profoundly, and perhaps so arrogantly, been avoiding. By late December, as the holidays approach, 3-eye atlas will be fading again. It will be receding from the sun, moving out of Virgo and into the constellation Leo, heading back out toward the orbit of Jupiter, which it will pass in March of 2026. After that, it will journey through the lonely outer reaches of our solar system, past the heliopause, and back into the infinite, silent darkness of interstellar space, likely never to return. This is our one and only chance. One way or another, December will give us answers. Not all the answers, perhaps, but enough. Enough to know whether we are simply watching the greatest and strangest comet show of our generation, or whether we are witnessing the first chapter of the greatest upheaval in human understanding since we first realized that the Earth was not the center of the universe. The telescopes are ready. The equations are prepared. The world is watching. Now we wait for 3-eye atlas to emerge from behind the sun and show us what it really is. To truly grasp the depth of the 3-eye atlas mystery, we need to go beyond the speculation and the circumstantial evidence and dive headfirst into the cold, hard numbers, the actual measurements that simply do not make sense, no matter how many times scientists run the calculations. This is the science that is keeping astronomers awake at night. Let's start by revisiting the most famous ghost in modern astronomy, the WOW signal. August 15, 1977, the Big Ear Radio Telescope at Ohio State University, a sprawling array of metal mesh, was conducting a routine SETI survey, patiently listening to the cosmic static. Suddenly, it detected something that, according to our understanding of the universe, should not exist. A powerful narrowband signal at a frequency of 1,420.4 megahertz, almost precisely on the hydrogen line. It was not the chaotic, broadband noise of a natural cosmic event like a pulsar or a quasar. It was a clear, focused, and seemingly artificial transmission. It lasted for exactly 72 seconds, which was the precise duration the telescope has been would take to sweep across a stationary source in deep space as the Earth rotated. The signal was astonishingly strong, 30 times louder than the background noise. On the raw data printout, the computer represented the signal's intensity with a sequence of numbers and letters. The values climbed from the normal background noise of 1s and 2s up through the 5s, 6s, and then for a brief stunning moment, it peaked at U, the highest value the system could possibly print before it ran out of alphanumeric characters. The astronomer on duty, Jerry Emin, saw this impossible sequence and, in a moment of pure scientific astonishment, circled it and wrote one word in the margin. Wow. They searched for it again. For years, for decades, the Big Ear telescope and countless other, more powerful observatories pointed at that same patch of sky in the constellation Sagittarius, hundreds and hundreds of times. They found nothing. A signal never repeated. It was a single piercing shout in the cosmic darkness, followed by an unbroken 48-year silence. It became astronomy's most famous and frustrating mystery, evidence of nothing, proof of nothing, but a tantalizing clue that was impossible to forget. Now, let's fast forward to 2025 and trace the path of 3I Atlas backward through space. When you account for its incredible velocity of 60 kilometers per second and map its trajectory back through the galaxy, you can calculate where it was on that fateful day in 1977. The answer: it was roughly 600 astronomical units from Earth. That's 600 times the distance from the Earth to the Sun, a staggering 90 billion kilometers away. For an object at that mind-boggling distance to produce a signal strong enough for the Big Ear telescope to detect strong enough to register as 30 times the background noise, it would require a transmitter of almost unimaginable power. The calculations show it would need to be outputting somewhere between 0.5 gigawatt and 2 gigawatts of sustained power. Let me be clear, that is not a battery. That is not a generator. That is the power output of a full-scale nuclear reactor, all of its energy focused into a beam narrow enough to travel across 90 billion kilometers of space and still be screamingly loud when it arrived. Could a comet do that? Absolutely not. Not with any physics we currently understand. Comets do not generate gigawatts of power. They do not emit coherent narrowband radio signals. They do not, by sheer coincidence, broadcast at the exact frequency that happens to be the universal marker for technological civilizations that are searching for each other. But an object that was designed to be found, an object that needed to announce its presence with a single powerful, unmistakable pulse before it entered the inner solar system. That is exactly how it would behave. One strong, clear shout to get our attention. Then silence, because you wouldn't want to give away your precise position until you were ready. Now let us move from the physics of radio waves to the chemistry of the object itself. The data from the Very Large Telescope that showed nickel without iron. In nature, these two elements are inextricably linked, bonded together from the moment of their birth. When a massive star dies in a supernova explosion, it forges the heavy elements of the universe in its final incandescent inferno. In these nuclear processes, an isotope called nickel-56 is created, which then decays into iron-56. They are created together, bound together in the same minerals, and blasted out into space as an inseparable pair. Every single meteorite we have ever analyzed, every asteroid, every comet from our solar system, shows them together. The ratio varies slightly depending on the local environment, but they are always both present. 2I Borisov, the interstellar comet that came before 3I Atlas, showed perfectly normal nickel-to-iron ratios. But 3I Atlas is an anomaly. There is no known natural process at the extremely low temperatures that 3I Atlas is experiencing that can separate these elemental twins. But technology can. On Earth, we do it every single day. The process of smelting, of chemical refinement, of producing high-purity nickel alloys for use in electronics and specialized applications, requires the active removal of iron contaminants. This industrial process leaves a distinct, unmistakable signature: nickel without iron. The scientists who published the data from the VLT tried every conceivable natural explanation. Maybe there were unusual chemical pathways in the comet's ice. Maybe it was made of exotic minerals formed under conditions we've never seen before. Maybe it was some quirk of dust grain physics that we don't yet understand. But every single one of their hypotheses ran into the same insurmountable wall. The temperature is simply too low. The environment is wrong. This should not be happening. And the process isn't static, it's dynamic. The amount of nickel being produced is increasing exponentially as the object gets closer to the sun by a power law of roughly 9. This isn't random outgassing. This is a process that is actively ramping up as the available solar energy increases. It looks, for all the world, like something is powering on. And then there is the tail, the single most iconic feature of a comet, and in the case of 3I Atlas, perhaps the most visually arresting and physics-defying anomaly of them all. For as long as humanity has been watching the skies, we have known one simple, reliable rule. A comet's tail always points away from the sun. It is one of the foundational, unshakable principles of planetary science. The reason is simple and elegant. Solar radiation pressure. Photons, the very particles of light streaming from the sun, have no mass, but they do have momentum. When these countless trillions of photons strike the tiny dust particles in a comet's coma, they transfer that momentum. It's an infinitesimally small push on each individual particle, but it is relentless constant, and over time, it overcomes the comet's own weak gravity and drives the dust particles outward away from the sun, creating the beautiful ethereal tail we see. Every single comet ever photographed, from Halley's to Hale-Bopp, has shown this. The tail always points away from the sun. Always. Except for 3I Atlas. The Hubble image from July 21st is unambiguous. Computer enhancement of the data makes the anomaly even clearer and more undeniable. There is more scattered light, more stuff, extending sunward than there is extending anti-sunward. It is a tail that points the wrong way. It is like seeing a flag in a hurricane pointing directly into the wind. It is so fundamentally wrong that it forces you to question not the observation, but the nature of the object itself. Now, science abhors a vacuum, and brilliant minds immediately went to work trying to find a natural explanation for this impossible observation. Avi Loeb and his colleague Eric Siraj published a complex model suggesting how this could happen. But the conditions it requires are incredibly narrow and specific. Their model proposes that the object is shedding large ice fragments, but only from its sun-facing side. These fragments would have to be of a very specific size large enough to resist being immediately pushed away by solar radiation pressure, but small enough to still scatter visible light efficiently. And the evaporation rate of these fragments would have to be just right, so that they survive long enough to create the observed distribution before they sublimate into nothing. On paper, the physics works. It is theoretically possible. But it is possible in the same way that it is theoretically possible to flip a coin 50 times and have it land on heads every single time. The laws of physics do not forbid it, but the sheer, staggering improbability of it makes you wonder, with a deep and unsettling feeling, if the coin is weighted. And this has become the repeating pattern with 3I Atlas. Every single one of its 7 anomalies has a potential, if exquisitely contrived, natural explanation. Each one, in isolation, could be dismissed as a fluke. The impossible mass can be explained if you assume it is made of some uncommonly dense material we've never seen before. The 1 in 20,000 trajectory can be explained if you just accept that a statistical miracle happened. The industrial chemistry can be explained if you're willing to invent exotic, low-temperature chemical processes that have never been observed anywhere else in the universe. The wrong-way tail can be explained if you assume a perfect Goldilocks-style ejection of specifically sized ice fragments. Each explanation is plausible on its own, but they are not in isolation. They are all happening in the same object, at the same time. They stack. 7 layers of special pleating, 7 instances of 3I Atlas, being a 1 in a million, or in some cases, 1 - in -20 - 1000, exception to the no rules. At what point does the scientific principle of Occam's razor the preference for the simplest explanation begin to cut in the other direction? At what point does piling coincidence upon coincidence become a far more complex and convoluted explanation than the simple, elegant, and terrifying alternative? At what point does the simplest explanation stop being it as a natural object that is breaking 7 fundamental laws of physics and probability, and start being, it was designed? That is the question that scientists are wrestling with in the quiet of their offices as 3I Atlas hides behind the sun. And it is a question that may soon be answered, not by a comet, but by events unfolding much, much closer to home. On October 1st, 2025, just as the mystery of 3I Atlas was reaching a fever pitch, something else happened that barely made the news, but is perhaps just as unsettling. An object, an asteroid now named 2025 TF, passed within 419 kilometers of the Earth's surface. At that altitude, astronauts live and work aboard the International Space Station. At that altitude, our most valuable commercial and military satellites orbit in carefully tracked paths. This object, the size of a small car and moving faster than any bullet ever fired, screamed through that exact same airspace just above the South Pole, and we had absolutely no idea it was coming. We only discovered it 6 hours after it had already passed us by. Meanwhile, on the surface of Mars, our rovers have found what NASA itself is calling the clearest sign of ancient life we have ever discovered. Patterns in a rock that, if found on Earth, would be considered slam-dunk evidence of fossils. In congressional hearings, shocking new footage has just been revealed showing a military missile striking an unidentified object off the coast of Yemen. And the object didn't explode. It just kept flying. The sun is entering what physicists are calling a last gasp phase of its solar cycle, one that could light up our skies with auroras more intense than anything seen in decades. 3 other comets, all of them a brilliant, eerie green, are racing toward us right now, and one of them might become visible to the naked eye within weeks. NASA has furloughed 15,000 employees while in a desperate race with China to return to the moon. And a private company is about to launch the most powerful rocket ever built for what might be its final make-or-break test flight. This is not science fiction. This is the reality of October 2025. The story of 3I Atlas is not happening in a vacuum. It is one thread in a much larger, more complex, and more extraordinary tapestry of events that are all unfolding right now, right above our heads. If you are ready to dive deep into what is really happening in our cosmic neighborhood, hit that like button and subscribe, because we are about to spend the next hour unpacking the most extraordinary and underreported space news of our generation. Tell me in the comments where you're listening from, and which of these stories shocks you the most. And if you want to help our community grow, please share this video. Thank you for always having our back. Let's begin with the asteroid that slipped through all of our defenses. We, as a species, have spent billions upon billions of dollars building a planetary defense system. It is a silent global network of sentinels, a web of telescopes scattered across the Earth, from the mountains of Arizona to the deserts of Chile, all scanning the night sky, night after night, without fail. Their sole purpose is to catalog every moving object, to calculate their trajectories, and to ensure that nothing dangerous, nothing civilization-ending, ever approaches our world without warning. And for the big ones, the system works remarkably well. We track the asteroids that could wipe out cities or even continents months, years, sometimes even decades in advance. We have a plan. We are prepared. But on October 1st, 2025, our entire multi-billion-dollar detection network failed. It failed to spot something until that something was already in our rearview mirror, a cosmic bullet that had already grazed our temple. The object, Asteroid 2025 TF, measures somewhere between 1.2 and 2.7 meters in diameter. Not a planet killer, certainly, but roughly the size of a compact car, a dense boulder of rock and metal. And it was traveling at 20.9 kilometers per second. That's nearly 13,000 miles per hour, a velocity so extreme it's difficult to even comprehend. It's fast enough to cross the entire continental United States, from Los Angeles to New York, in less than 4 minutes. At its closest approach, just after midnight UTC on October 1st, this rock passed a mere 419 kilometers above the icy wilderness of Antarctica. To put that number in perspective, the International Space Station, humanity's home in the heavens, orbits at an altitude of around 420 kilometers. This asteroid flew through the exact same neighborhood where astronauts live and sleep. It passed closer to us than many of the satellites that provide our GPS, our weather forecasts, and our global communications. The Catalina Sky Survey in Arizona finally detected it at 2:35 in the morning, Eastern Time on October 1st, using the powerful Bok telescope at Kitt Peak National Observatory. But here is the detail that should keep you awake at night, the detail that exposes the true vulnerability of our planetary defense system. That detection came at 6 hours and 36 minutes after the asteroid had already made its closest approach. We didn't see it coming. We saw it leaving. Now this event, this flyby of asteroid 2025 TF, officially ranks as the second closest asteroid pass ever recorded in human history. The current record holder, an asteroid named 2020 VT4, passed even closer back in November of 2020, coming within a terrifying 370 kilometers of the Earth's surface. But that one, too, we only detected after the fact. There is a pattern here, and it is not a comforting one. The issue isn't incompetence. The astronomers and engineers who run these detection systems are among the most brilliant and dedicated people in the world. The problem is one of physics and resources. Small asteroids like 2025 TF are incredibly, fiendishly difficult to spot. They are often as dark as charcoal. They are moving at incredible speeds, and they simply don't reflect enough sunlight for our telescopes to see them until they are practically on top of us. Our entire network is optimized to catch the big ones, the asteroids larger than 150 meters that would cause regional or even global devastation. Those we track with a religious fervor. But for objects in the 1 to 10 meter range, there are literally millions of them, and they are nearly invisible ghosts in the cosmic shooting gallery. Here is where the story gets even more interesting, and in a way, more unsettling. When asteroid 2025 TF was finally spotted, scientists had to work backward, using the very brief glimpse they had to try and calculate its orbit. They determined that it follows a long, elongated path around the Sun, an orbit that takes roughly 2.06 years to complete. But all of those numbers, all of those precise-sounding calculations, come with an enormous, flashing asterisk of uncertainty. The orbit is what astronomers call poorly constrained, with a condition code of 7 on a scale of 0 to 9, where 9 is the most uncertain. What this means, in plain English, is that the calculations are based on just a one-day observation arc. It's like trying to predict the final destination of a speeding car by looking at it for just a single second. Predicting where this particular asteroid will be in the future is more educated guesswork than it is hard science. Additional observations will be required to refine its trajectory and to assess whether it might pose any threat during future encounters with Earth. Think about what this truly means. An object passed closer to the Earth than some of our most valuable satellites, and we have only the vaguest, haziest idea of where it came from or where it's going next. It could return. It could be on a collision course with Earth decades from now, or it might never come close again. We simply don't know. The uncomfortable truth is that asteroids of this size hit the Earth's atmosphere far more often than most people realize. The famous Tunguska event in 1908, which flattened 830 square miles of Siberian forest with the force of a hydrogen bomb, was likely caused by an object only 30 to 50 meters across. That's larger than 2025 TF, but not by an overwhelming margin. If 2025 TF had been on a collision course instead of a near-miss trajectory, it would have exploded in our upper atmosphere with the force of several kilotons of TNT. Not enough to end civilization, but certainly enough to shatter every window in a major city if it happened to detonate over one. And we wouldn't have known it was coming until we saw the flash. Scientists are calling this a wake-up call. This near miss has reignited urgent discussions about the need to improve our detection capabilities for these smaller, but still potentially dangerous near-Earth objects. Because if there is one thing this silent, terrifying encounter has made crystal clear, it's that our cosmic neighborhood is far busier and far more dangerous than our current systems can fully monitor. The question isn't whether another asteroid will surprise us. The question is when, and whether we will be lucky enough for it to miss again. But while we are worrying about the rocks flying past our planet, something far more profound and potentially far more important for the future of humanity has been unfolding on the silent, frozen surface of Mars. Something that might just answer one of the oldest and most fundamental questions we have ever asked. For over a year, on the distant, frozen surface of Mars, a single, unassuming rock has been keeping some of the world's most brilliant scientists awake at night. It's not because the rock is particularly large or made of some exotic material. It's because of what is written on its surface. Patterns that, if they were found anywhere on Earth, would be considered an unmistakable, slam-dunk, smoking gun sign of life. On September 10, 2025, after a year of the most rigorous, painstaking, and skeptical scientific scrutiny imaginable, NASA made an announcement that sent quiet but profound ripples through the scientific community and beyond. The Perseverance rover, as discovery of potential biosignatures in a rock sample named Sapphire Canyon, had officially passed the trial by fire of peer review and was being published in the world's most prestigious scientific journal, Nature. The acting NASA administrator, Shakira Duffy, in a moment of rare and startling candor, put it bluntly, this very well could be the clearest sign of life that we've ever found on Mars. To understand the significance of this, we need to rewind to July 24th, 2024. On that day, the Perseverance rover, our robotic geologist on Mars, drilled into an arrowhead-shaped rock nicknamed Shalyazao, a Navajo word meaning Shayava Falls in the planet's Jezero crater. As soon as the rover's instruments began to analyze the core sample, they detected something intriguing. The rock's surface was covered in a series of small, circular features that the science team began to call leopard spots. These weren't just pretty random patterns. They were distinct chemical signatures that, on our planet, are often created by microbial life. Imagine tiny, single-celled organisms consuming organic matter in the sediment and then excreting specific minerals as waste products. Over millions of years, these waste products can build up, creating distinctive mineral patterns that become fossilized in the rock. The leopard spots on this Martian rock contain two very specific minerals, vivianite and greigite. Now, these are not common minerals. They both form under very specific conditions, in low-temperature, water-rich environments. Vivianite is a hydrated iron phosphate that, on Earth, is often found in sediments near decaying organic matter. Greigite is an iron sulfide that certain forms of microbial life actually produce as a byproduct of their metabolism. Finding either of these minerals would be interesting. Finding them together in the same tiny spots and finding them co-located with organic carbon, the building block of life as we know, it creates what geologists call a compelling potential biosignature. It is a trifecta of evidence, a chemical fingerprint that points, with tantalizing clarity, toward a biological origin. But here is where the story gets even more interesting. The rock itself, Shalyaz, sits in a geological formation called Bright Angel, which is located along the edges of an ancient river valley, known as Nerefa Vallis. We know from our orbital data that this valley once carried enormous amounts of water into Jezero crater more than 3 billion years ago. The valley is roughly a quarter of a mile wide, which suggests it was carved by a powerful, sustained flow of water over very long periods of time. The mudstones and the finely layered sediments in the Bright Angel Formation tell the story of a dynamic, life-friendly environment where periods of fast-flowing river currents alternated with long periods of calm, standing water. This is precisely the kind of environment where, on a young Earth, microbial life not only existed, but thrived. The discovery was particularly surprising because the Bright Angel Formation contains some of the youngest sedimentary rocks that the Perseverance mission has investigated. The prevailing hypothesis had always been that if we were going to find signs of ancient Martian life, we would have to look in the oldest possible rock formations, remnants from Mars's earliest, wettest, and most habitable era. But finding these incredibly strong biosignatures in relatively younger rocks suggests something profound. It suggests that Mars might have remained habitable for a much longer period than we previously thought. Or, perhaps even more excitingly, that life, once it got started, managed to persist and adapt even as the planet around it grew colder, drier, and more hostile. Now, before we get carried away, we need to be very clear about what a potential biosignature actually means. This is not, repeat not, definitive proof of life. It is tantalizing, compelling evidence that requires much, much more investigation. As the mission's lead scientist, Dr. Katie Stackmorgan, rightly emphasized, astrobiological claims, particularly those related to the potential discovery of past extraterrestrial life, require extraordinary evidence. The year-long, grueling peer review process that led to the publication in Nature was deliberately designed to be as rigorous as possible. Outside scientists with no connection to the mission spent an entire year scrutinizing the Mars 2020 team's data and analysis. They tried to find any and every alternative explanation, any possible non-biological, purely geological process that could create the same patterns. And while they found some theoretical possibilities, none of them fit the totality of the evidence nearly as well as the biological hypothesis. What makes this discovery so powerful is the sophistication of the instruments that Perseverance used. It used an instrument called Sherlock, which detected a strong spectral signature for organic carbon, and it used an instrument called PIXL, which mapped the precise distribution of chemical elements across the rock's surface. Together, these instruments revealed that the organic matter and the telltale minerals weren't just present in the same rock. They were co-located in the same tiny spots, clustered together in a way that strongly, powerfully suggests a direct connection. On Earth, this kind of co-location happens all the time in microbial mats, where bacteria consume organic compounds and then precipitate out minerals as waste, creating distinctive fossilized patterns. The leopard spots on this Martian rock look remarkably similar. But there is a catch, and it is a very big one. To truly, definitively confirm whether these features have a biological origin, to move from potential biosignature to proof of life, scientists need to get that rock sample back to Earth. They need to analyze it in our most advanced laboratories, with instruments far too large and complex to ever send to Mars. Laboratories here can perform isotopic analysis to see if the carbon has the specific isotopic ratio that is a hallmark of life. They can examine the molecular structure of the organic compounds to see if they are the specific types that life produces. They can conduct experiments that are simply not possible with a rover's limited toolkit. This is where the scientific imperative runs headlong into the harsh reality of political drama. The Mars Sample Return Mission, a joint effort between NASA and the European Space Agency, was designed to do exactly this, to retrieve the precious samples that Perseverance has been carefully collecting and deliver them to our labs. But the mission has been plagued by budget overruns and schedule delays. And now, the proposed White House budget for 2026 would cancel the current Mars sample return program entirely, zeroing out its funding. Meanwhile, China has announced its own ambitious plans for a Mars sample return mission, which could launch as early as 2028. If the United States does not bring back Perseverance's samples, it is very possible that China will be the first nation in history to return Martian material to Earth, and they may well be the ones who get to definitively answer one of the greatest questions in the history of science. Are we alone? The geopolitical implications are staggering. For now, the Sapphire Canyon sample, with its leopard spots and its tantalizing secrets, sits safely tucked inside a sealed titanium tube on the Martian surface, waiting. It contains what might be the most important scientific discovery in human history, frozen evidence that could rewrite our understanding of life's place in the universe. But while that sample waits, something else has been unfolding much closer to home, in our own skies. Something that is forcing our own governments to confront questions they would much rather avoid. On September 9, 2025, in a hearing room on Capitol Hill, a United States congressman from Missouri, named Eric Burleson, walked up to the podium and, with the quiet gravity of the moment, played a video that nobody in the public had ever seen before. The footage, dated October 30th, 2024, is stark and monochrome. It shows a bright, perfectly spherical object moving silently against a dark background. Then suddenly, a streak of light enters the frame from the side. It is a Hellfire missile, one of the most advanced and destructive weapons in the U.S. military's arsenal. The missile streaks across the screen and appears to strike the object directly, dead center. And then, what happens next defies everything we think we know about physics and warfare. The object doesn't explode. It doesn't fragment into a million pieces. It doesn't even appear to slow down or alter its course. The missile, a weapon designed to obliterate tanks, simply seems to bounce off, continuing on its own trajectory, while the orb, completely unscathed, keeps flying. That's the Hellfire missile smacking into that UFO and just bouncing right off, Congressman Burleson said, narrating the incredible footage for the committee. And it kept going. He paused, letting the impossible image sink in, and then he asked the one question that has been echoing through the corridors of the Pentagon and the intelligence community ever since. "I'm not going to speculate what it is," he said, "but the question is, why are we being blocked from this information consistently?" The video, it was revealed, was captured by an MQ-9 Reaper drone, a sophisticated surveillance and attack aircraft operating off the coast of Yemen. At the time, the waters near Yemen were an active combat zone. U.S. Navy ships and aircraft were on high alert, protecting commercial shipping lanes from a barrage of missiles and drones being fired by Houthi militants. American forces were regularly shooting down real, tangible threats in that very region. But this object, whatever it was, did not behave like any known drone or missile, and it certainly did not respond to a direct hit from a Hellfire the way any known aircraft, from any nation on Earth, ever would. When the Department of Defense was asked to authenticate the video and provide details about the encounter, their response was a masterclass in bureaucratic stonewalling. A defense official told reporters, "We do not have anything to provide on this." A DOD spokesperson added, even more bluntly, "I have nothing for you." This refusal to comment, this wall of silence, only served to deepen the mystery and fuel the speculation that the government was hiding something extraordinary. But the Yemen video wasn't the only bombshell revelation from the hearing. A procession of military veterans, men with spotless service records and active security clearances, testified under oath about their own direct, personal encounters with what the government now officially calls unidentified anomalous phenomena, or UAPs. An Air Force veteran named Dylan Bolin described an incident from 2012 when he stepped outside for a cigarette break during an overnight shift at Langley Air Force Base in Virginia, one of the most secure military installations in the country. A massive, silent, triangular aircraft, he testified, hovered directly above him for several minutes, completely motionless. Then, according to Boland, the object rapidly ascended to the altitude of a commercial jet in a matter of seconds and vanished at an impossible speed. Boland, being a good airman, reported the incident through the proper official channels. He was eventually interviewed in 2023 by ARO, the Pentagon's new All-Domain Anomaly Resolution Office, the very office that is supposed to be seriously investigating these incidents. But instead of being taken seriously, he claims his report was dismissed. And worse, he says he faced a campaign of workplace retaliation. His security clearance was manipulated, and he was effectively blacklisted from future employment at federal intelligence agencies. His testimony painted a damning picture of a system that doesn't just fail to investigate UAP encounters, but one that actively and vindictively punishes the brave men and women who dare to come forward. This hearing was about something much bigger than just individual sightings. It was about government transparency, or the stunning lack of it. As Representative Ana Paulina Luna, who chairs the task force, stated in her opening remarks, for too long, the issue of unidentified anomalous phenomena has been shrouded in secrecy, stigma, and in some cases, outright dismissal. This is about national security, government accountability, and the American people's right to the truth. Here is what makes this moment in history fundamentally different from the decades of UFO speculation that have come before it. The witnesses are not fringe conspiracy theorists. They are decorated military personnel with first-hand operational experience. The evidence is not grainy, out-of-focus cell phone video from someone's backyard. It is crystal clear sensor data from our most advanced military platforms, captured during active combat operations in contested airspace. And the resistance to disclosure isn't coming from some shadowy, mythical men in black. It's coming from official Pentagon offices, from the very people who are tasked and funded by our tax dollars to investigate these incidents. ARO, the Pentagon's office, has consistently maintained that it has no verifiable evidence of extraterrestrial activity or technology. But critics point out that many of the most compelling cases, including the Yemen incident, seem to be explained away with logic that simply doesn't add up. Take the infamous Go Fast video from 2015, which showed a fast-moving object appearing to skim at incredible speed above the ocean waves. IRO analysts eventually concluded that it was an optical illusion, likely a weather balloon, and that its apparent high speed was just a trick of parallax. But the Navy fighter pilots who witnessed these objects with their own eyes, not just on their sensors, insist that these mundane explanations do not match their direct, personal experiences. Some analysts have suggested that the Yemen orb might also be a balloon drifting in high-altitude winds. And the missile? Perhaps it simply missed, and the angle of the footage just made it look like a direct hit. But former senior intelligence official Lou Elizondo, who also testified at the hearing, pushed back hard on that theory. "We've never seen a Hellfire missile hit a target and bounce off," he said. "When a Hellfire makes a kinetic strike on something solid, there's usually not much left of whatever it is it's hitting. It's very, very destructive. So, what are we left with? We are left with two possibilities, neither of which is particularly comforting. Either the U.S. military encountered something with technology so far beyond our own capabilities that it can withstand a direct missile strike and continue on its way without even flinching. Or there is a mundane terrestrial explanation for this event, and for some reason, our government officials are refusing to share it publicly. And this is not an isolated incident. The National UFO Reporting Center logged over 2,000 UAP sightings in just the first 6 months of 2025, a significant increase from previous years. The Pentagon itself has received more than 750 new reports from military personnel between May 2023 and June 2024 alone. Whatever is happening in our skies, it is happening more frequently, and more credible people are paying attention. And while our governments grapple with objects in our atmosphere that they cannot explain, something far more predictable, but no less dramatic, has been unfolding just above our heads, driven by the star that makes all life on Earth possible. In October of 2024, scientists made a quiet announcement that should have dominated headlines around the world, but somehow got lost in the relentless noise of our daily lives. The sun, our star, the engine of our world, officially reached solar maximum, the peak of its natural 11-year activity cycle. For most people, it sounds like dry academic astronomy, the kind of thing that matters to researchers in white lab coats, but has no real effect on our everyday existence. But what is happening to our star right now is anything but academic, and the most intense, most beautiful, and potentially most dangerous effects might still be ahead of us. Here is the secret about solar maximum that nobody ever tells you. The peak of solar activity doesn't mean the show is over. In fact, it means we are now entering a phase of the solar cycle that could actually produce more geomagnetic storms and more spectacular auroras than the maximum itself. Think of it like a magnificent firework. It doesn't burn brightest at the moment of ignition. It burns brightest in its final, explosive, cascading moments before it fades back into darkness. Over the next 2 years, the sun is about to give us its last gasp, and that gasp could light up the skies across the entire planet. Dr. Pepil Breck, a solar physicist with the Norwegian Space Agency, put it plainly. It's good news for aurora chasers, as peak auroral activity occurs a few years after solar maximum. Thus, we should have several years, still with very high aurora activity. Let that sink in for a moment. We are not at the end of the show. We are just now approaching the grand finale. To understand why, we need to talk about what drives the auroras, the northern and southern lights, in the first place. During solar maximum, the sun's surface becomes covered with sunspots. These are vast, dark regions of intense magnetic activity, some of them larger than the Earth itself, where the star's powerful magnetic field lines become tangled, stressed, and twisted like cosmic rubber bands. When these field lines finally snap and reconnect, they release unimaginable amounts of energy in the form of solar flares, and something called coronal mass ejections, or CMEs. A single CME can hurl billions of tons of superheated plasma, very stuff of the sun, out into space at speeds exceeding 1,000,000 miles per hour. When that plasma cloud, a tsunami of charged particles, slams into the Earth's protective magnetic field, it triggers a geomagnetic storm. This storm funnels those particles down toward the poles, where they collide with the atoms of oxygen and nitrogen in our upper atmosphere, causing them to glow in the shimmering dancing curtains of green, pink, and purple light that we call the aurora. But here is where the story gets more interesting and counterintuitive. After solar maximum, as the sun begins its slow decline towards solar minimum, the number of these explosive flares and CMEs starts to decrease. You would think that would mean fewer auroras, but you would be wrong, because during this declining phase of the solar cycle, something else begins to happen. Long-lived coronal holes begin to form on the sun's surface. These are vast, dark regions in the sun's atmosphere where the magnetic field lines, instead of looping back down to the surface, open up directly into space. This allows a continuous, high-speed stream of solar wind to escape, like water from a fire hose. These high-speed streams can persist for weeks, even months at a time, battering the Earth's magnetic field with a sustained, relentless pressure that can trigger geomagnetic storms that are just as dramatic and sometimes even more long-lasting than those caused by a single CME. Solar physicist Dr. Shutdown explained it this way. During the declining phase, we actually have more geomagnetic storms. Maybe the sun's actual eruption activity slows down a bit, but because you still have coronal holes forming, and you still have quite a few eruptions, when you add those together, you get more frequent and sometimes more intense auroral displays. We are already seeing this play out in real time. In the first week of October 2025, Earth experienced 5 consecutive days of geomagnetic activity, all driven by a fast solar wind stream from one of these coronal holes. At their peak, solar wind speeds reached an incredible 768 kilometers per second. Even as the speeds gradually declined, the wind was still strong enough to trigger what are known as G1, or minor geomagnetic storm levels. And the result? Auroras danced across the northern latitudes, visible on some nights as far south as New York. Photographers in Iceland, Norway, Canada, and the northern United States captured absolutely stunning images of vibrant green, pink, and purple lights rippling and pulsating across the sky. And this was just a warm-up. Scientists are now forecasting that the current solar cycle, Cycle 25, could maintain these high levels of geomagnetic activity well into 2027 or even beyond, driven by this powerful 1-2 punch of lingering eruptions and persistent coronal holes. But there's another factor at play, one that has nothing to do with the sun itself and everything to do with the Earth. Our planet's orientation during the equinox season, which we are still in right now, makes our magnetic field more susceptible to these solar onslaughts. During the equinoxes, the angle of Earth as magnetic field relative to the incoming solar wind creates conditions that are perfect for allowing more of those charged particles to penetrate our defenses and trigger stronger, more vibrant auroral displays. It's like a door that is usually half closed is suddenly thrown wide open. Now, the practical implications of all this solar fury go beyond just pretty lights in the sky. Intense geomagnetic storms can disrupt our vital radio communications. They can interfere with our GPS systems. They can cause the orbits of our satellites to decay, and in the most extreme cases, they can even threaten our power grids on the ground. During the Great Geomagnetic Storm of March 1989, a powerful CME caused the entire province of Quebec, Canada, to lose power for 9 hours. Transformers overheated and melted, circuit breakers tripped, and millions of people were plunged into darkness. The storms we're seeing now are not that severe, but they are still strong enough to cause major headaches for satellite operators and for airlines who have to reroute flights away from the poles to protect their communication and navigation systems. For most of us, however, the main effect of the sun's last gasp will simply be one of profound cosmic beauty. Auroras are among the most spectacular and moving natural phenomena on Earth. The next 2 years might offer some of the best viewing opportunities in decades. If you live at high latitudes, you will have regular chances to see the lights. But even those of us at mid-latitudes, as far south as the central United States, might get to catch a rare glimpse during the stronger storms. The sun's fury is turning out to be a light show for the ages. But while our own star is painting our skies with fire, other, much more mysterious celestial visitors are approaching from the deep, cold darkness of space. And they are bringing their own unique and spectacular brand of spectacle. Something strange and wonderful is happening in the night sky in October of 2025. If you look up on the right night, from a dark location, far away from the glare of city lights, you might be able to see not 1, not 2, but 3 comets, all visible simultaneously in our skies. And all of them share a strange and beautiful characteristic. They are all glowing with an ethereal, emerald green light. All of them were discovered just this year. And one of them, the star of this cosmic parade, might just become bright enough for you to see with your own unaided eyes, a rare and magical gift in an era when most comets remain frustratingly dim, reserved only for those with powerful telescopes. The undisputed headliner of this cosmic show is Comet C 2025A6, better known as Comet Lonios, named after the Mount Lemmon Observatory in Arizona, where it was first spotted on January 3, 2025. At the time of its discovery, it was at a staggeringly faint magnitude of 21.5, so faint that astronomers initially thought it was just another small, uninteresting asteroid. It wasn't until follow-up observations revealed a tiny, condensed coma and the faintest hint of a tail that its true, much more exciting nature became clear. For most of this year, Comet Lonios remained an obscure object, tracked only by professional astronomers and a handful of dedicated amateurs, largely ignored by the public. The early predictions suggested it would peak at a modest magnitude of 9 when it reached its closest point to the Sun in early November, bright enough for a decent backyard telescope, but nowhere near naked-eye visibility. Then, in mid-August, something completely unexpected happened. After emerging from its passage behind the Sun, when it was hidden from our view, observers immediately noticed that the comet was significantly, dramatically brighter than all the models had predicted. By August 19th, its magnitude had jumped to 11. A short, spiky tail had become visible. And the brightening didn't stop. It just kept getting brighter and brighter. By late September, Comet Lonios had reached a magnitude of 8, easily visible with a simple pair of binoculars or a small telescope. Astrophotographers around the world began capturing absolutely stunning images, showing not just the bright green nucleus and its surrounding coma, but a long, active, and beautifully detailed ion tail streaming away from the Sun, complete with intricate twirls, knots, and streamers as the charged particles of the tail interacted with the solar wind. By September 30th, the comet had brightened to a magnitude of 6.6, right on the threshold of human vision. Its ion tail stretched for about 3 degrees across the sky, that is the width of 6 full moons side by side. The current projections, which are being updated almost daily as new observations pour in, suggest that Comet Lonios will reach a peak magnitude of 4, and possibly even 3, when it makes its closest approach to Earth on October 21st, at a distance of 56 million miles. That puts it squarely in the territory of naked-eye visibility. From truly dark sky sites, far from the light pollution of our cities, people might actually be able to spot it as a faint, fuzzy, otherworldly star. And unlike many comets that reach their peak brightness when they are too close to the Sun to be observed safely, Lonios will be perfectly positioned in the evening sky, visible in the west about an hour after sunset. The best viewing is expected to be around Halloween and into early November. For those of us in the Northern Hemisphere, this is a truly once-in-a-lifetime opportunity. Comet Lonios follows an extremely elongated, almost parabolic orbit. It may not return to our skies for another 1,350 years, if it ever returns at all. But Lonios isn't alone in this celestial parade. Just a few weeks ago, another comet, C2025R2 Swan, was discovered. We didn't see it sooner because it was hidden in the Sun's glare. It was actually spotted by 2 sharp-eyed amateur astronomers, Vladimir Bezagli and Michael Matiazzo, in images taken by the Swan instrument aboard NASA's SOHO spacecraft, a space-based telescope designed to study the Sun. This comet is now moving away from the Sun, so it won't get much brighter, but it will get easier to see as it moves into the darker night sky. On October 20th, it will make its closest approach to Earth, and this weekend, it will pass within a single degree of the planet Mars, creating a beautiful and rare photo opportunity for astrophotographers. The third member of this cosmic trio is Comet C2025K18, Atlas, named after the asteroid Terrestrial Impact Last Alert System, a survey designed to find near-Earth asteroids, but which is clever enough to spot comets too. K18 Atlas is fainter than the other 2, but it is steadily getting brighter as it approaches the Sun, and will be a nice target for patient observers with binoculars or small telescopes in the pre-dawn sky. So why are all 3 of these comets glowing green? The magical color comes from a molecule called diatomic carbon, which is made of 2 carbon atoms bonded together. As the comets approach the Sun, the intense solar radiation breaks apart the larger organic molecules in their icy cores, releasing this diatomic carbon into the gassy coma. This molecule is particularly good at absorbing ultraviolet sunlight and then re-emitting it at a very specific wavelength of light that our eyes perceive as green. The closer they get to the sun, the more carbon gets released and the greener they glow. And interestingly, there is a fourth green comet currently visible in our skies, though it is much, much harder to spot. It is our old, mysterious friend, the interstellar visitor 3I Atlas. It, too, has recently abandoned its more crimson hue and turned a brilliant emerald as it interacts with our sun as radiation in ways we are still struggling to understand. But that, as we know, is a story for another time. Comet Lonios has already exceeded all of our wildest expectations, and there is a genuine, palpable excitement among astronomers about how bright it might become. The unpredictability is part of what makes comets so captivating. They are not like planets or stars, following their steady, predictable paths. Comets are wild, erratic, and beautifully chaotic. They can brighten in sudden, unexpected outbursts. They can fragment without warning, or they can fizzle into obscurity just when they were supposed to put on their best show. Predicting a comet's behavior is like trying to predict the weather 6 months in advance. You can make educated guesses based on the physics and past behavior, but nature always reserves the right to surprise you. And in October of 2025, we are getting a month full of wonderful surprises. 3 green comets racing through our skies at once, one potentially visible to the naked eye. The sun blazing with activity, auroras dancing at mid-latitudes, asteroids sneaking past our defenses. And on Mars, a rock covered in patterns that might just be the fossilized remains of ancient life. But while all of this natural, cosmic drama unfolds above our heads, one company down here on Earth is preparing to launch the most powerful and ambitious machine ever built by human hands. It is a machine that could either revolutionize the future of space travel or become another spectacular, explosive footnote in the long and difficult history of ambitious failures. October 13th, 2025. Mark that date on your calendar, because it is a day of reckoning. If all goes according to plan, and with SpaceX, that is a very, very big if, the world will witness the 11th test flight of Starship, the tallest, heaviest, and most powerful rocket ever built by human hands. But this is not just another launch in a long series of tests. This flight, Flight 11, will be the last time we ever see this version of Starship, known as version 2, take to the skies. Everything that comes after this will be bigger, more powerful, and in theory, more reliable. The question that hangs heavy in the humid Texas air is whether version 2 can go out on a high note, a blaze of glory, or whether it will add one more spectacular, heart-stopping explosion to a year that has already seen far too many. Let's be blunt and address the elephant in the room. 2025 has not been a kind year for the Starship program. The year started with a brutal 1-2 punch of back-to-back explosive failures that shook the confidence of even the most ardent SpaceX supporters. Flight 7 in January saw the upper stage, the spacecraft itself, known as SHIP, experience a catastrophic breakup during its initial ascent. 4 of its 6 powerful Raptor engines shut down prematurely, causing a fatal loss of attitude control and a complete loss of telemetry. The vehicle's fiery, tragic breakup was visible from Florida, Jamaica, and the Turks and Caicos Islands. Then came Flight 8 in March, which, for a few glorious moments, appeared to be a stunning success. The massive Super Heavy booster performed perfectly and was caught in a breathtaking maneuver by the giant mechanical arms of the launch tower. But the triumph was short-lived. The upper stage, Ship 34, suffered 4 engine shutdowns during its own burn, lost control, and broke apart 9.5 minutes after liftoff. Then came Flight 9 in May, which used the program's first ever reused Super Heavy booster, another major milestone. But again, the upper stage failed to complete its mission. 3 flights in a row, 3 ships lost. 3 painstaking investigations, followed by 3 rounds of redesigns and solemn promises that next time it would be different. Flight 10, in August, finally broke the losing streak. For the first time, everything worked. The booster splashed down as planned in the Gulf of Mexico. The ship completed its full suborbital arc, survived the brutal heat of atmospheric re-entry with its heat shield intact, and made a controlled, soft-water landing in the Indian Ocean. It even managed to successfully deploy a batch of Starlink satellites during its flight, a critical demonstration of its future commercial capability. For the first time in months, the engineers at SpaceX and its supporters around the world could finally, collectively exhale. Now comes Flight 11, scheduled for 6:15 p.m. Central Time on October 13th, launching from the sprawling Starbase facility in South Texas. The mission profile looks similar to the successful Flight 10, but with some key differences that make it far more ambitious and potentially far more risky. The booster being used, designated B-15, previously flew on the ill-fated Flight 8 back in March. It was the one that was successfully caught by the tower, making it flight-proven hardware. This time, it's equipped with 24 flight-proven Raptor engines, meaning both the booster itself and most of its engines have already been through the hellish stresses of a real launch and landing. But here is the twist. Instead of attempting another daring tower catch, B-15 will perform a unique and complex landing burn engine configuration that SpaceX plans to use on the next generation of the booster, Super Heavy version 3. The booster will ignite a staggering 13 engines at the start of its landing burn, then transition to a new 5-engine configuration during what's called the divert phase, where it steers itself toward its landing target. Previously, this phase used only 3 engines. The new 5-engine approach adds crucial redundancy in case of the spontaneous engine shutdowns that have plagued so many previous flights. Finally, the booster will transition to its 3 center engines for the very end of the landing burn, entering a full hover just above the waters of the Gulf of Mexico before shutting down and dropping into the water. SpaceX is explicitly calling this a stress test. They want to measure the real-world vehicle dynamics as the engines shut down and restart during these different phases. If it works, it validates their design for the future. If it fails, well, at least it fails over the open ocean instead of near the multi-billion-dollar launch site. The upper stage, Ship 38, has its own incredibly ambitious agenda. It will attempt to deploy 8 Starlink simulators, mock-ups that are similar in size and mass to the next-generation Starlink satellites that SpaceX plans to launch commercially. These simulators won't actually operate as satellites. They are on the same suborbital trajectory as the Starship and will burn up on re-entry. But deploying them is a crucial test of the mechanisms and procedures needed for real revenue-generating missions. Ship 38 will also attempt to relight one of its Raptor engines while in the vacuum of space, demonstrating the critical ability to perform orbital maneuvers. This capability is absolutely essential for any future missions to the Moon, Mars, or anywhere else that requires precise changes in orbit. Then comes the heat shield test, and this is where things get deliberately, terrifyingly dangerous. The engineers have intentionally removed tiles from several key areas of Ship 38's heat shield to stress test the most vulnerable spots on the vehicle. Some of the missing tiles are in areas that don't even have a backup ablative layer underneath. If the superheated plasma of re-entry, which is hotter than the surface of the sun, finds its way through those gaps, it could burn through the vehicle's structure and cause a catastrophic failure. But SpaceX needs to know. They need to know exactly where the weak points are. They need to know how much punishment the ship can take before it fails. And the only way to find out is to push it until something breaks. Assuming Ship 38 survives its trial by fire, it will perform a dynamic banking maneuver during its final descent, testing the subsonic guidance algorithms that will be needed for future flights that return all the way to the launch site. Then will come a final landing burn and hopefully a gentle splashdown in the Indian Ocean, all in one piece. All of this, every single one of these risky maneuvers, is building toward version 3, the iteration of Starship that SpaceX believes will finally make the system fully operational. Version 3 ships will be larger, with more propellant capacity and greater payload volume. The boosters will use even more engines and generate even more thrust. Most importantly, the design will incorporate all the hard-won, often explosive lessons learned from 10 previous test flights. But none of that future promise matters if Flight 11 goes sideways. If Ship 38 breaks up during the heat shield stress test, critics will point to it as evidence that the entire design is fundamentally flawed. If the booster's new landing burn configuration fails, it raises serious questions about whether their entire approach is viable. And if anything goes wrong in a spectacular public way, it could severely impact SpaceX's crucial relationship with NASA, which is counting on Starship to land the next American astronauts on the Moon. During the Artemis 3 mission in 2027, the stakes could not possibly be higher. Starship is not just another rocket. It is the centerpiece of SpaceX's entire vision for the future of humanity in space. It is the machine that is supposed to make access to orbit cheap, routine, and reliable. It is the vehicle that is supposed to enable the colonization of Mars. It is supposed to revolutionize the satellite industry, refuel itself in orbit, and eventually carry human beings on journeys that right now exist only in the realm of science fiction. But first, it has to stop exploding. Flight 11 is SpaceX's chance to prove that version 2 can end its run on a successful note, building the crucial momentum they need to enter the version 3 era. The launch window opens on October 13th. Millions of people around the world will be watching. And in the final, silent seconds before ignition, every single one of them will be thinking the exact same thing. Please, don't blow up. While SpaceX races against time and its own explosive history to perfect its giant rocket in the Texas sun, another nation, on the other side of the world, is quietly and methodically executing a mission that is already billions of miles from Earth. It is a mission heading toward a target so strange, so mysterious, that it might hold the secrets to our own moon's violent, cataclysmic past. On May 28, 2025, at 1:31 a.m., local time in China, a Long March 3B rocket, a workhorse of the Chinese space program, climbed into the dark pre-dawn sky above the Xichang Satellite Launch Center. Most of the world barely noticed. There were no breathless live streams, no charismatic CEO tweeting updates. But what that rocket carried into the void of space might just answer one of the strangest and most poetic mysteries in our entire cosmic neighborhood. Is there a lost piece of the moon, a cosmic orphan, floating in orbit around the Earth, pretending to be an asteroid? The spacecraft is called Tianwen-2, the second mission in China's ambitious and increasingly impressive planetary exploration program. Tianwen-1, its predecessor, went to Mars, successfully delivering both an orbiter and a rover that are still operating on the red planet today. Tianwen-3, the next in the series, will attempt to bring samples back from Mars, a mission that could potentially beat NASA's own troubled Mars Sample Return program to the punch. Tianwen-4 will be an even more audacious grand tour, visiting both Jupiter and Uranus in a single decade-long mission. But Tianwen-2 has a target that is much closer to home, and in many ways, far more mysterious. It is an object called Kamoa-Leia, also known by its official designation, Asteroid 2016 HO3. Kamoa-Leia is what astronomers call a quasi-satellite. It is a near-Earth object that, from our perspective, appears to be orbiting our planet like a tiny second moon. But it's an optical illusion. In reality, it is orbiting the Sun, but its orbit is so perfectly synchronized with Earth's that it's trapped in a delicate gravitational dance with our planet. It never strays too far away, and it never gets pulled into a true orbit. It just dances around us as we both journey around the sun. The asteroid itself is tiny, measuring between 40 and 100 meters across, roughly the size of a Ferris wheel. And it has been performing this peculiar, beautiful dance for at least a century, and possibly for much, much longer. But here is what makes Kamoa-Leia truly, uniquely strange. Its spectrum, the specific way it reflects sunlight, is a nearly perfect match for weathered lunar rocks, the very rocks brought back by the Apollo astronauts. In 2021, an astronomer named Ben Sharkey led a groundbreaking study that suggested this tiny asteroid might not be an asteroid at all. It might, in fact, be a massive boulder that was ejected from the surface of our own moon by a powerful, ancient impact. The name, Kamoa-Leia, comes from a Hawaiian creation chant and alludes to an offspring that travels on its own, a breathtakingly poetic description of a lost fragment of our moon, wandering through space but always staying near its parent. If this incredible theory is correct, Kamoa-Leia could be a scientific treasure trove. It could tell us about the moon's violent bombardment history, the size and energy of the impacts that have shaped the lunar surface over billions of years. It could even provide us with pristine samples of lunar material that haven't been contaminated by their long exposure on the lunar surface or by their fiery passage through Earth's atmosphere. But there is another, equally fascinating possibility. Kamoa-Leia might instead be a regular, main-belt asteroid that somehow migrated from its original orbit between Mars and Jupiter and ended up in this strange, semi-captured orbit near Earth through a series of complex gravitational interactions that we don't yet fully understand. That would be just as exciting, because it would reveal new, unknown migration pathways through the solar system, secret cosmic highways that our current models don't predict. The only way to know for sure, to solve the mystery of its origin, is to go there, to touch it, and to bring a piece of it back home. And that is exactly what Tianwen-2 is designed to do. On June 6th, just over a week after its flawless launch, the China National Space Administration, CNSA, released the mission's first update. The spacecraft was operating normally and had already traveled more than 3 million kilometers from Earth. They released a simple, almost mundane photo showing one of Tianwen-2's golden solar arrays, photographed by an onboard engineering camera, floating against the profound blackness of space. But that simple image confirmed everything. The spacecraft was alive, healthy, and on its way. Tianwen-2 is now on a year-long journey to Kamoa-Leia. When it arrives in 2026, it will spend another full year orbiting the tiny asteroid, studying it from close range, mapping its shape and surface, and measuring its mass and composition. This will be an extraordinarily difficult and dangerous task. Kamoa-Leia is the smallest asteroid ever targeted by a space mission, and it is also the fastest rotator ever visited by a spacecraft, spinning on its axis once every 28 minutes. Trying to land on, or even just touch, something that small and spinning that fast is like trying to grab a child's spinning top while you re-blindfolded. China plans to use 3 different redundant sampling techniques. The first is a hovering approach, where the lander will attempt to match its rotation with the asteroid while collecting material from the surface. The second is a touch-and-go maneuver, similar to the technique that NASA's OSIRIS-REx and Japan's Hayabusa 2 missions used with incredible success. The spacecraft will briefly make contact with the surface, grab a sample, and then immediately lift off. The third, and most ambitious, approach involves using drills on the lander's legs to physically anchor the spacecraft to the asteroid's surface, allowing for a more controlled, longer-duration sampling process. The goal is to collect at least 100 grams of material, a little more than 3 ounces. That might not sound like much. But when you are sampling an asteroid 40 million miles from Earth with a robotic spacecraft that has to operate almost completely autonomously because of the long communication delays, every single gram is precious. Once the samples are safely secured, Tianwen-2 will begin its long journey home. In 2028, about 2.5 years after it first launched, it will approach the Earth and release a re-entry capsule containing the precious asteroid samples. That capsule will have to survive atmospheric entry speeds of 12.1 kilometers per second, even faster than the Apollo capsules returning from the Moon, generating temperatures and pressures that will push Chinese heat shield technology to its absolute limits. But here's where the mission gets even more ambitious. After releasing the sample capsule, the mothership Tianwen-2 will not retire. Instead, it will use the Earth's gravity for a slingshot maneuver, flinging itself onto a completely new transfer orbit toward a completely different and even stranger target, a main belt comet named 311P Pan-STARRS. The journey will take another 7 years. If everything works, Tianwen-2 will arrive at this strange, hybrid object, an object that has the characteristics of both an asteroid and a comet sometime in the mid-2030s. The entire mission is designed to last a decade. One spacecraft, 2 completely different and challenging targets. A sample return from a quasi-satellite, followed by a rendezvous with a main belt comet. It is audacious, complex, and if successful, will demonstrate a level of deep space operational capability that only a handful of nations on Earth possess. More importantly, it is a direct and unmistakable challenge to American dominance in space. And as we will see, it is happening at the very moment that America's own space agency is facing an existential crisis. At precisely 12:01 A, on October 1st, 2025, the United States federal government officially shut down. And in the silent, empty hallways of NASA centers across the country, a light went out. Within hours, 15,000 NASA employees, the scientists, the engineers, the dreamers, the builders received their official furlough notices and were sent home. Laboratories that were probing the secrets of the universe went quiet. Offices that were planning the future of humanity in space were closed. Ongoing research, the very lifeblood of the agency, ground to a halt. For most of NASA, work simply stopped. But not for everyone. A small, dedicated fraction of NASA's workforce, just over 3,000 people, were classified as essential and were required to keep working. They will not receive paychecks during the shutdown. They will log their long hours and hope, against hope, that Congress will eventually approve back pay when the government reopens. But they have to show up. They have to come to work. Because the work they do, quite literally, keeps our spacecraft and our astronauts alive. At Mission Control in Houston, the operations for the International Space Station continued without interruption. The ground controllers, the unsung heroes of human spaceflight, are still monitoring the station's delicate life support systems, preparing and validating the thousands of commands that are sent up every day and standing ready to respond to any emergency. If those controllers were furloughed, the astronauts living and working 250 miles above our heads would be at risk. So they work, unpaid, while politicians in Washington, D.C. argue over budgets. The other major, and very telling, exception to the shutdown is the Artemis program, NASA's ambitious and high-stakes effort to return human beings to the surface of the Moon. The acting administrator, Shakira Duffy, made the agency's priorities crystal clear in a social media post just before the shutdown. She wrote, "China is not going to the Moon with good intentions." The implication was obvious, and it was a message intended not just for the public, but for the politicians holding the purse strings. Beating China back to the lunar surface is now being framed as a national security imperative, one that is important enough to exempt thousands of government, workers, and private contractors from the furlough. But here is the story that the shutdown doesn't tell you, the deeper and more damaging crisis that has been unfolding at NASA long before October 1st. Earlier in 2025, the White House's Office of Management and Budget, along with the acting NASA administrator, issued a series of directives to slash the agency's workforce by more than 4,000 employees. From the end of September through January 9th, 2026, thousands of long-time, dedicated NASA employees are leaving the agency through deferred resignation offers. These are not furloughs. These are permanent departures. By the end of this process, over 20% of NASA's entire workforce will be gone. And it's not just the numbers that are devastating. It's who is leaving. This exodus has included top-tier, world-class talent. The engineers who designed the systems for the Artemis program. The brilliant scientists who manage our multi-billion-dollar planetary missions. The irreplaceable experts in highly specialized fields like power systems, propulsion, and life support. One NASA employee at the Johnson Space Center in Houston, speaking on the condition of anonymity for fear of retaliation, said the agency has already lost at least one of its foremost experts in power systems. A critical, almost irreplaceable loss, as the agency struggles to develop the nuclear reactor that will be needed to generate power for a sustainable moon base. This brain drain is being driven by the relentless uncertainty of the budget and the intense political pressure from the administration. President Trump's proposed budget for the fiscal year 2026 requests the lowest level of NASA funding since 1961 when adjusted for inflation. 1,961. That was the year that Alan Shepard became the first American in space. The budget proposal includes a devastating, almost unbelievable 47% cut to NASA's science programs. If that budget were ever to be enacted, it would cancel 41 active missions, including spacecraft that have already been launched and are currently making discoveries. Let that sink in for a moment. 41 missions canceled. Not missions that are still on the drawing board. Missions that are already flying. Telescopes that are already observing distant galaxies. Probes that are already exploring other planets. Satellites that are already monitoring the health of our own Earth. The proposal would literally require NASA to turn off spacecraft that have been journeying through the solar system for years, in some cases for decades, wasting billions of taxpayer dollars and erasing a flood of future knowledge that can never be recovered. The list of missions on the chopping block reads like a greatest hits of human space exploration. The Nancy Grace Ronong Space Telescope, a flagship observatory designed to discover hundreds of thousands of new exoplanets and to survey over 1 billion galaxies to unravel the mysteries of dark energy, would be canceled, despite being nearly complete. The OSIRIS-APEX mission, which is currently on its way to study the asteroid Apophis during its close flyby of Earth in 2029, would be shut down mid-flight. The Mars Sample Return mission, despite already having the precious, potentially life-bearing samples sitting on the surface of Mars, waiting to come home, would be abandoned, effectively ceding the discovery of life on Mars to China. Even the missions that have already proven their immense worth, the legends of the space program, are not safe. The Chandra X-ray Observatory, which has been observing the high-energy universe since 1999 and making discoveries that have reshaped the entire field of astrophysics, is on the chopping block. Even the Hubble Space Telescope, perhaps the single most famous and beloved scientific instrument ever built by human hands, could see its mission support so drastically reduced that it would effectively be eliminated. The crisis at NASA is not about a temporary shutdown. It is an existential threat to the future of American leadership and scientific discovery in space. And it is happening right now. The proposed cuts to NASA's budget don't just threaten our exploration of the distant cosmos. They strike at the very heart of our ability to understand and protect our own planet. Earth science missions, the unsung heroes of the space program that monitor the effects of climate change, that track the devastating pace of deforestation, that measure the inexorable rise of our sea levels, and that provide the essential data for our daily weather forecasts and for disaster response, are also targeted for cancellation. Even the planetary defense programs, the very systems designed to find and track the next killer asteroid, would see their funding dramatically reduced. The irony is almost too painful to bear, coming just weeks after an asteroid snuck up on us, completely undetected. Whistleblowers from within the beleaguered agency have begun to speak out, noting that the administration's actions, imposing a budget that has not been approved by Congress, are not just damaging, but potentially illegal, defying the constitutional separation of powers. NASA's legal office should know better, one anonymous employee said. They should know that what this administration is doing is breaking NASA procedures, NASA regulations, and not following the will of Congress. But the violations continue, often hidden from public view, as the agency is slowly and systematically dismantled from within. The human cost of these cuts extends far beyond the gates of NASA's own centers. Universities and research institutions across the country rely on NASA grants to fund their research and to pay the salaries of their graduate students, the next generation of scientists and engineers. When these grant payments halt during shutdowns or are eliminated by budget cuts, entire research programs can collapse overnight. Professors find themselves unable to pay their teams. Students, midway through their PhDs, lose their funding and are forced to abandon their careers. Decades of accumulated expertise and institutional knowledge, built through painstaking effort, can evaporate in a single budget cycle as brilliant people are forced to leave the field entirely. Meanwhile, our international partners are watching this slow-motion train wreck with a growing sense of nervousness and dismay. NASA's collaborations with the European Space Agency, the Japanese Space Agency, and others on massive multi-decade missions like the Artemis program and Mars sample return involve legally binding agreements and shared costs. When NASA unilaterally changes its plans or cancels missions, it strains the international relationships that took decades to build. It undermines America's reputation as a reliable and trustworthy partner in the grand endeavor of scientific exploration. But perhaps the most damaging and least tangible consequence of this crisis is the loss of public trust and, crucially, of scientific momentum. Space exploration is a long game. It is a marathon, not a sprint. Missions can take years, sometimes decades, to plan, to build, to launch, and to execute. You cannot simply pause a planetary probe in the middle of its flight to Jupiter and then restart it a year later. You cannot delay a mission and expect the precise alignment of the planets to wait for you. The laws of orbital mechanics, unlike political priorities, are non-negotiable. When the continuity of these long-term programs is broken, when missions get canceled and then restarted, when talented people leave and are not replaced, the damage compounds. Every canceled mission is a discovery that is not made. Every lost expert is decades of experience that vanishes forever. Every shutdown is a loss of momentum that has to be painfully and expensively rebuilt from scratch. And yet, even in this dark moment, there is still hope. The space community and its supporters are fighting back. Protests have been held outside NASA's headquarters in Washington, D.C., with employees and ordinary citizens demanding full funding and an end to the devastating cuts. Lawmakers from both political parties, particularly those who represent the districts that are home to major NASA facilities, have pushed back hard against the administration's proposals. The House and the Senate have both put forward their own appropriations legislation that significantly exceeds the president's draconian request, though as of early October, nothing has been finalized. The question is whether this resistance will be enough, whether Congress will assert its constitutional authority over federal spending and reject the budget cuts that would effectively cripple American leadership in space for a generation, whether the public will rise up and demand that their representatives protect the agency that gave us the moon landings, the Mars rovers, the Hubble and Webb telescopes, and decades of discoveries that have expanded human knowledge and inspired generations of children to look up at the stars and dream. Because right now, NASA, and by extension, America's future in space stands at a crossroads. One path leads to continued exploration, to profound scientific discovery, and to a renewal of American leadership in the cosmos. The other path leads to a managed decline, to canceled missions, to lost expertise, and to a future where we are forced to watch from the sidelines as other nations, like China, surge ahead. The choice isn't being made by the scientists or the engineers. It is being made by politicians and by bureaucrats, many of whom will never see, or perhaps never understand, the long-term consequences of their decisions. And while they debate, the people who have dedicated their entire lives to exploring the universe are forced to watch as their life's work is dismantled, piece by piece. This is the world of October 2025. Asteroids fly past our planet, completely undetected. Potential signs of ancient life sit frozen and waiting on the surface of Mars. Unidentified objects in our own atmosphere shrug off our most advanced weapons. The sun blazes with the fire of its final, most active phase. Comets, green and mysterious, race toward us from the darkness. A private company in Texas builds the most powerful rocket in history, while the government agency that once put human footprints on another world struggles just to keep the lights on. The universe doesn't care about our budget debates or our political squabbles. It will continue its ancient, silent, and magnificent dance, utterly indifferent to whether we choose to watch, to study, to explore, or to simply look away and pretend that the cosmos doesn't matter. But it does matter. Every discovery we make, every question we answer, every mystery we unravel, adds to the sum total of human understanding. It enriches our culture, it drives our technology, and it reminds us that we are all part of something vastly, beautifully, and terrifyingly larger than ourselves. And right now, we are in grave danger of forgetting that fundamental truth at the exact moment in our history when we need to remember it the most.